Let's see the next problem, one more problem. See this. Example, I think 11, example 11. Right? Let's see the next problem. See this problem also. Tn is equal to 1 if n is equal to 1, otherwise 2t n minus 1 plus n if n greater than 1. Tn is equal to 1 if n is equal to 1, otherwise 2t n minus 1 plus n if n is greater than 1. Right? So this one how to solve? Let's see this problem also. We done until now nice problems, right? Please concentrate this also. So which one is important? The else part. Read the else part. Tn is equal to 2t n minus 1 plus n. Right? Can you help me now? If you read this one, Tn is equal to 2t n minus 1 plus n. Can you help me if n value 100? What is the answer? T 100 is equal to 2t 99 plus 100. T 50 is equal to 2t 50 minus 1 means 49 plus 50. Right? I am thinking you are fine now. Let's start. It is a nice problem. Please you take care. It will trouble you if you don't listen. See this. Tn is equal to 2t n minus 1 plus n. Tn is equal to 2t n minus 1 plus n. Now can you help me? If you substitute one more time, what is the answer? 2t n minus 2 plus n minus 1. Bracket should be there. If anyone don't keep bracket, it is the wrong answer. Please be careful. Plus n. Right? Simplify this. 2 square t n minus 2 plus 2 into n minus 1 plus n. Right? Don't do any simplification. 2 square is there, 2 square. If required, after third round we will do. Right? Until third round, don't do any calculations. Right? Let's go one more round. 2 square 2t n minus 3 plus n minus 2 outside as it is 2 n minus 1 plus n. I am not doing anything as it is. Whatever I done in the previous problem, same thing I am doing. 2 cube t n minus 3 plus 2 square n minus 2 plus 2 n minus 1 plus n. Now one more thing I want to ask you. Please help me now. Right? First round non-recursive term. Right? First round non-recursive term. Right? And one more thing is going to be second round non-recursive term. It is the first round non-recursive term. It is the second round non-recursive term. Can you help me now? Both are same or different? Both are different. Different means series coming. First level non-recursive term, second level non-recursive term differ, means series coming. Which series if you want to know, right? Do 3 times first. Yes, I done 3 times, right? After third round over, this is the answer. After third round over, this is the answer. Some people are asking, what should we do now? After third round over, what you have to do, you know very well. What is the answer? Right? After third round over, whatever is came in the last place, right? It should be in terms of 3. Let's check here. 3 rounds over, whatever is came, it should be in terms of 3. Let's check here. 3 round, it is the 3. It is also 3. It is the 3 means, it is the 2. Right? I think it is the 2 means, it is the 1. Right? It is the 1 means, it is the 0. I think it is working. Right? So if you do 3 times, 3, 3, it is the 3 means, it is the 2, it is the 2 means 1, it is the 1 means 0. Some people are asking, why 1 only difference? Because always you are subtracting 1, 1 only difference came. Always you are subtracting 1, 1, so 1 only difference came. If you subtract to 2, 2 like in the previous problem, 2 difference will come. I am thinking that you are absolutely fine now, right? Let's go k time. If you go k time, what is the answer? It will become 2 power k n minus k. 2 power k n minus k plus it will become 2 power, right? K minus 1 n minus k minus 1. Right? It is the k means it is the k minus 1. I hope everyone is fine. See, 2 means 2. K minus 1 means k minus 1. Same way, 2 power k minus 2. Right? N minus k minus 2. Right? It is keep on going. Right? It's keep on going until last one. What is the last one? 2 power 0 n minus 0. Right? Like this. Next one, some people are asking, what is the termination condition? This should be 1. N minus k is equal to 1. Right? N minus 1 is equal to k. K is n minus 1. Replace now. It will become k is n minus 1. because always if you subtract 1, 1, 1, 1, right, n minus 1 times you have to do, so that 1 will be there. It will become 2 power n minus 1, k is n minus 1, right, of n minus of n minus 1, so that 1 will be there. It will become, it is a n minus 1, k value n minus 1 means it should be n minus 2, 2 power n minus 2, right, n minus of n minus 2, 2 power n minus 3, n minus of n minus 3. It will continue, right, it will continue until, right, last one. What is the last one? 2 power 0, n minus 0. Right, let's simplify this. Simplify. If you simplify this one, right, let me check. If you simplify 2 power n minus 1 into n cancel, what is the answer? 1. 2 power n minus 2, right, I think n cancel, what is the answer? 2. 2 power n minus 3, right, n cancel 3, and so on. What are the last few things? Last few things let me write here. What is the answer? 2 power 1, n minus 1. Right, last few things, right, please check. This one is going to be 2 power 0, n minus 0, like that. I am thinking you are absolutely fine now, right? Let me write in the reverse order. Everything is okay. Do whatever way convenient to you. Let me write in the reverse order. I am writing reverse order. Please be careful. T of n is equal to, reverse order I am writing, 2 power 0. What is the answer? N minus 0 means n. 2 power 0. What is the answer? Into n. N minus 0 means n. Right? Next one. What else? 2 power 1, n minus 1. Right, next one, 2 power 2, n minus 2. Next one, what are the last few things? Last few things, 2 power n minus 3 into 3. 2 power n minus 2 into 2. Right, please check. Next one, 2 power n minus 1 into, right, 1, like this. Check here. 2 power 0, reverse order I written, I am not done anything, reverse order. Tn is equal to 2 power 0 into n, 2 power 1 into n minus 1, 2 square into n minus 2, and so on. 2 power n minus 3 into 3, 2 power n minus 2 into 2, 2 power n minus 1 into 1, right, this is the Tn. Now some people are asking me, how many people will go? What is the purpose of this problem? Please let me know. Many problems I said, why I selected this problem also, what is the reason? So the reason is in this one, different kind of series is coming. I want to explain to you. In this problem, different kind of series coming. I want to solve it. The things which I didn't cover until now, right, that is coming, right, I want to cover that, that is the reason I given. See this one, Tn is equal to, right, this one. How to solve this kind of series, I want to explain. Let me check. How to solve this kind of series, I want to verify, I want to explain to you, that is the reason I am doing. Let's see this one, this series if you observe clearly, see this one, 2 power 0, 2 power 1, 2 square, 2 cube, right, like that. If you observe clearly, in every term, only see first part. In every term, see only first part. It is a GP series. Right, Tn is equal to one series there, it's okay. But inside that series, if you observe, right, in every term, see only first part. In every term contain 2 parts. Every term contain 2 parts. See only first part. If you see only first part, it is a GP series. Next one. In every term, see only second part. See only second part. Right? It is a AP series. I think, right, first term is a GP series. Second one is going to be a AP series. So what I want to say indirectly, directly in this problem is going to be, please be careful. What I want to say indirectly, directly in this problem is going to be how to solve a series which contain combination of AP, GP. That is the purpose of this problem. How to solve a series which contain combination of AP, GP. Tn is the combination of AP, GP. How to solve it? Right? I will explain. GP there, AP there. Can you read the GP series? 2 power 0, 2 power 1, 2 square and so on, 2 power n minus 1. Can you read the AP series? N minus 1, n minus 2, n minus 3 and so on. Right? 1. Right? Like that. I hope everything is fine now. Right? Now see the next story. Everything is fine now. See the next story. How to convert the APGP, right? Now, very simple, very simple. If you want to convert to APGP, right? If you want to solve the APGP series, very simple. Can you help, what is the GP series? 2 power 0, 2 power 1 and so on. 2 power n minus 1. How many terms are there total? 0 to n minus 1. N terms are there. 0 to n minus 1, n terms. How to solve APGP series? I will give the answer. See this one. APGP series, how to solve is, see this one. APGP convert into GP. APGP series convert into GP series. Some people are asking how. Very simple. Can you help me now? Can you help me now? See this one. Tn is equal. Let me write once again. How to convert APGP into GP? See this one. How to convert AP and GP into GP? How? I am explaining. Standard procedure is there. Just follow it. Tn is equal. Let me write as it is. 2 power 0 into n. 2 power 1 into n minus 1. 2 square into n minus 2. Lastly, what is the answer? 2 power n minus 2 into 2. 2 power n minus 1 into 1. Right? It is the APGP series. That is the Tn. It's okay. Can you help me now? APGP into GP how? Can you say GP series? GP series, what is the R value? Right? Everyone, how to get the R value? Second one by first one. 2 power 1 by 2 power 0. 2 power 1. 2 square by 2 power 1. 2. So, APGP, how to convert into GP is like this one. It is the Tn. Can you see in the GP series what is the R value? 2. So what will you do? Multiply total Tn by R value 2. R value in the GP is 2. Multiply total series by 2. So when you do that, can you see what is the answer? When you do that, what will happen? Multiply this one by 2. This will become, if you multiply this entire series by 2, means every term we have to multiply by 2. Can you multiply first one by 2? What is the answer? It will become 2 power 1 into n. It will become 2 power 1 into n. This one. What is the answer? This one I multiplied, this one came. This also multiply by 2. What is the answer? 2 square into n minus 1. This also multiply. What is the answer? 2 cube into n minus 2. Like that it is going on. Now can you help me? How many people will give the answer to me? Who is there before this? Who is there before this? 2 power n minus 3 into 3. Multiply by 2. What is the answer? 2 power n minus 2 into 3 will come. This also multiply by 2. What is the answer? 2 power n minus 1 into 2. This also multiply by 2. What is the answer? 2 power n into 1. This also multiply by 2. 2 power n minus 1 into 2 means 2 power n. Right? Like this. Nothing there. See, 2 power 0 becomes, if you multiply by 2, 2 power 1. Because of it will become 2 power 1. I written here. If you want, you can write here. If you multiply by 2, 2 power 0 becomes 2 power 1. Because of it became 2 power 1, I written close to 2 power 1. Anything is okay, you can write. If you want, you can write here. Because of here gap is there. Lastly, one extra key. See this one. In the Tn, how many terms are there? 2Tn also same term. The only thing is power is incremented by 1. Because the power is incremented by 1, I think it is almost like one right shift happened. So here gap is there. Because of here gap, here one extra came, here gap is there. Same thing, right? Both will be same. Simply Tn in the given in the GP series, what the R value find out, multiply total Tn by R value. Yes, I multiplied. After multiplying, subtract. This is the standard procedure. How to convert into APGP into GP? GP series, find the R value, multiply by total Tn by R. After multiplication is over, subtract. Tn minus 2Tn. Subtract this. Tn minus 2Tn is equal to, subtract 2 power n. 2 power 0 into n minus 0. What is the answer? 2 power 0 into n. This is same. This one minus this one is going to be same. Can you subtract this one? What is the answer? This one, I think 2 power 1 common. N minus 1 minus n. What is the answer? I think 1 extra. I think minus 1 will come. Right? Next one same. 2 square into. Right? N minus 2 minus 1. I think this is 1 extra. Right? So smaller one minus bigger one. What is the answer? Minus 1 again. Next one. 2 cube minus 1. It will continue like this one. Right? Can you say what about this one? What about this one? Let me check here. 2 minus 3 means minus 1. Same. 2 power n minus 2 into minus 1. Here 2 power n minus 1 into minus 1. Right? Into minus 1. 2 power n minus 1 into minus 1. What about this one? Right? What about this one? Minus 2 power n. Minus 2 power n. Right? Like that. Now, I think if you are comfortable, can you say what is this value? Right? After this one, if you simplify, let's check. I am not done anything. Tn, 2Tn, just I subtracted. It will becomes now minus Tn. is equal to, let's see one by one. It is that simply n. It is simply n, it's okay. Can you help me know what is the next one? Minus 2 power 1 minus 2 square minus 2 cube minus 2 power 4 and so on. What is the last one? Minus 2 power n minus 2 minus 2 power n minus 1 minus 2 power n. Right? This is equal to n minus, if you common, 2 power 1, 2 square, 2 cube and so on. What is the last one? 2 power n. Right, this will become n minus this series, GP series, sum of n terms in the GP series. What is the formula? A into 2 into r power 2 power n minus 1 by r minus 1, 2 minus 1. It is n minus, right? Fine, it will become n minus, what is the answer? 2 power 2 into 2 power n minus 2. I think small calculations are over. It will become, what is the answer? 2 power n plus 1. Forget about small things, really not required. It is the minus Tn. You want minus Tn or Tn? Our actual problem is Tn. Tn is our actual problem. So what is the answer? Tn is equal to, reverse it, 2 power n plus 1 minus n. Plus becomes minus, minus 1 becomes plus. Forget about small thing. It will become, what is the answer? Big O of 2 power n plus 1, which will goes to 2 into 2 power n, which will goes to, right, big O of 2 power n. If you want, you can write theta also, because left side, right side, same answer. 2 into 2 power n. The purpose of this problem is going to be, if any final answer is 2 power n, it's okay. The purpose of this problem is going to be how to solve AP-GP series. If you want to solve AP-GP series, what is the first one? GP series, find the R value, multiply total series by R value. Afterwards, subtract. Right, after subtracting, do you believe or not, all AP terms are gone. See this one. After subtraction is over, all AP terms are gone. So, GPK. Previously, if you see the GP, 2 power 0, 2 power 1, 2 square, now that GP is K. If you, right, I am repeating once again, AP-GP series, how to solve? AP-GP series, if you want to solve, right, GP series, find the R value, multiply entire series by R value, afterwards subtract, then AP-GP become GP. You know very well how to solve the GP series. That is the same thing I done. Actually, I want Tn, but minus Tn came. If you want Tn, multiply by minus. So, minus becomes plus, plus becomes minus, finally 2 power n came. Answer of this problem is 2 power n. Purpose of this problem is how to solve this series. This only. Remaining all you know. AP, GP, how to solve. That is the only goal. This is the only goal. I done that. R value in the GP is 2, multiply total Tn by 2, afterwards subtract. Afterwards GP came, solve it. Finally 2 power n is the answer. Right? To this problem, answer is 2 power n. Theta also you can write, right, because left side, right side, bigger function is same. Theta of 2 power n. Right? Please be careful. Right? See this problem also. One more problem. See this one also. So what is the previous problem? Number 11. Now 12. Example 12. See this also. Very small problem. One small thing I left out. I want to cover that also. See this one. Tn is equal to 1 if n is equal to 1. That's okay. Tn is equal to 1 if n is equal to 1. That's fine. Now next one. See this one. T n by 2 plus c, where c is a constant. T of n is equal to 1 if n is equal to 1. Otherwise, Tn by 2 plus c, where c is a constant if n greater than 1. Right? This one, this constant story I am not covered, I am covering now. Now can you help me now? This is very tricky problem. Please see this. Small thing is pending, I am doing that also. Can you read the problem? Main thing. Tn is equal to Tn by 2 plus c. Tn is equal to Tn by 2 plus c. What is the c? C is a constant. What is the meaning? N changes, constant don't change. Some people are asking, sir, what is the meaning of this? I am repeating now. Tn is equal to Tn by 2 plus c. I am okay. Right? Can you help me? N value 10. What is the answer? T10 is equal to T10 by 2 plus c. It doesn't matter what is the n value. Can you help me? What is the T100? T100 is equal to T100 by 2 plus constant. So every time constant irrespective of n. That is the only thing I want to say to you in this problem. Let me do few times. See this one, very simple. Tn is equal to Tn by 2 plus c. What is the Tn by 2? What is the answer? T n by 2 square plus c already there, one more c. Next one, let me do one more time. T n by 2 cube plus c, already 2 c's are there. And one more thing I want to ask you, first level, second level non-recursive term is same, means series not coming, same coming. Right, 3 times I done, this is the story. Some people are asking after 3 times over, what we have to do? Just observe what is going on. Final answer should be in terms of 3c. It is a 3 c is k. Right, it is very simple. If I continue k time, what is the answer? It will become t n by 2 power k plus, what is the answer? If I do 3 times 3 c's k, if I do k time k c's will come k into c. Next one, some people are asking n by 2 power k is equal to 1, n is equal to 2 power k, log n base 2 is equal to k is log n base 2, substitute. It will become t 1 plus c into k value log n base 2. Right, what is the t1? 1 plus c log n base 2, which will goes to, what is the answer? Big O of log n base 2. Because of c constant, forget about it. This side constant, big O means here also constant. Left side, right side, bigger function same, theta also you can write. The answer of this problem is going to be log n base 2. What is the k value? Log n base 2. What is the purpose of this problem? What is the meaning of c? C is a constant. What is the meaning? N changes, it is c. N again changes, c only, right? So irrespective of n, right, it is always c, means constant. Final answer is going to be log n base 2 theta. So this is the example number 12. I'm requesting everyone. 12 problems I said to you. They are really nice problem. In every problem something you can learn. I repeated many times also. Please go through all of them. Right? First listen one time properly. Afterwards, right, take the problem and do yourself. At anywhere you stuck, you can see again. Right? Make your own notes also. Right, so that right, you can see the notes immediately. Seeing the videos again and again, lot of time consuming and all. When you done first time, right, afterwards, right, after when you done first time, what will you do? Right, just write the problem only. First listen, afterwards write the problem. Next problem also listen, afterwards write the problem. Like that, write all the problems. Afterwards you do your own. At anywhere you stuck, only that part you can see in the videos. Right, please be careful. I am thinking that you are almost okay. 12 problems I done. Every part I covered. If small, right, if at all anything is left out, right, in the total divide and conquer, you will see those kind of reconciliations only. Easily we can do that. This is the substitution method. To solve the recurrence relation, next method is recursive tree method. Previously we seen substitution method, now recursive tree method. Right? See when the recursive tree method will be applied and all, we can see now. Right? Let me take the first problem. Make sure that first problem onwards we will follow carefully. Right? Example 1. Recursive tree method, example 1. See this one. Tn is equal to t n by 3 plus t 2n by 3 plus n. It is the recurrence relation. This recurrence relation, how to solve using this method, I will explain now. If you are okay with one problem, right, you are okay with the other problems also. Right? How to solve this recurrence relation using this method, I will explain. So let me ask you one small line. When the people will go for recursive tree method, when the people will go for substitution method, can you guess? Right? You completed the substitution method. Now recursive tree method started. Right? Can you help me now? When the people will go for substitution method, when the people will go for recursive tree method? I think by seeing this example you will get to know. Right? When will you go? Right? See this one. If recurrence relation contain more than one recursive call, see this one. More than one recursive call. That may be 2, that may be 3 also. It is a non-recursive term. These are recursive term. If the recurrence relation contain more than one recursive call, then recursive tree method is better. More than one child will come. Then tree format will come. Again I am repeating now. When the people will go for substitution method, what is the answer? Only one recursive call is there. People will go for substitution method. More than one recursive call, recursive tree method. Right? Please be careful. More than one recursive call, recursive tree method better. The reason is, right, tree format will come.
Some people are asking in the substitution method, can't I go for the recursive tree method and all? Substitution method also recursive tree method kind of thing. The only thing in the substitution method, only one function call you are keep on substituting. That is the reason the substitution method will give one array tree, every time you are substituting one only you are substituting. Right? So first one will substitute, second one will come, second one will substitute, third will come, and so on. I think in the case of substitution method, right, tree will come one array tree, right? But here two array tree, three array tree, four array tree. So substitution method is nothing but normal linear format, right? What is the meaning of this one? Right? It looks like you are substituting again. That is also tree, that is unary tree, but it is a binary tree, ternary tree, something like that. Again, final conclusion, if I want to say simplest way, when will you go for substitution method? One recursive call is there, substitution method. More than one recursive call, recursive tree method. How to do this? I will explain now. See this one. Please be comfortable in this problem. Tn is equal to Tn by 3 plus T 2n by 3 plus n. Right, so n is actually there, initially n is there, right, that n, right, I think that n internally calling two people, right, T of n internally calling two people, function name is T, it's okay. This n will be divided into two parts, one side is n by 3, another side is 2n by 3. What is the meaning? Left, right, I think it is the left function call, it is the right function call, it is the non-recursive term, leave it. It is a non-recursive call, don't bother, right? Recursive calls we are talking about. See this one, n will be divided into two parts. Left is multiplied by 1 by 3. Right is multiplied by 2 by 3. Everyone, left is multiplied by 1 by 3 is nothing but divide by 3 by 1. Right is multiplied by 2 by 3 is nothing but divide by 3 by 2. But anyhow, n will be divided into two parts, right? One side is n multiplied by 1 by 3, another side n multiplied by 2 by 3. Right, everyone fine? Right, let's see this one. N divided into two parts, these two, right? And one more, some people are asking, n will be divided into like this, to divide this one, some cost it will take, that may be n. Yeah, right, see this one, n becomes two parts, right? Means you done division and all. To divide that it will take some time, that is n. Please be careful. One problem, please be comfortable. Recursive tree method, one problem I am explaining. See this one. Whenever you are doing substitution method, there also one non-recursive term will come. See, in every level one non-recursive term will come. Here also, in every level one non-recursive term will come. In the substitution method also, every level non-recursive term is there, recursive term is there. Recursive terms you keep on substitute. Here more than one recursive term. I think more than one time you have to substitute. Substitution method one time only you will substitute, but in the recursive tree method more than one time you have to substitute. There also in every level one non-recursive term, here also every level one non-recursive term. Other than this nothing there. Right? I am starting. See this one, left multiply by 1 by 3, right multiply by 2 by 3. If I want to talk in terms of division, left divided by 3 by 1, right divided by 3 by 2. Right? Fine. So let's see the answer now. Careful, one problem, please be careful. I am starting. See this one. N, this n, this n, this n. Right? N elements I have initially. This n, please be careful, this n. N elements I have, that n will be divided into two parts. Left is going to be multiplied by 1 by 3, right is going to be multiplied by 2 by 3. N will be divided into two parts, n by 3 to n by 3, like that divided. Divided it's okay, n will be divided in two parts, that's okay, but to divide it will take some cost maybe, that is going to be n, this is the n. Every level non-recursive term, please be careful, n is there, non-recursive term n will come. N is there, non-recursive term n will come, this n will be divided into two parts, that's okay. Similar story, recursion means what? Same thing will happen again and again. N there, non-recursive term n will come, this n will be divided into two parts. If you are okay with that, same thing, recursion, same thing will repeat. What is the meaning? This n by 3 will be divided into two parts. Left, whatever is there, left multiply by 1 by 3. What is the answer? N by 3 square. Right multiply by 2 by 3. What is the meaning? 2n by 3 square. But one thing, this n by 3 will be divided into two parts, it's okay. But one thing, n elements are there, it will take n times. Similar way, n by 3 is there, it will take n by 3 times. Same way here also. 2n by 3 there, left multiply by 1 by 3. What is the meaning? 2n by 3 square. Right multiply by 2 by 3. What is the meaning? 2 square n by 3 square. But this will also take some cost. What is the answer? N there, n time. 2n by 3 is there, 2n by 3. So n non-recursive term is n by 3 non-recursive term is n by 3, 2n by 3 non-recursive term is 2n by 3. So because of 2 recursive call in this level, 2 non-recursive values are there. Can you say total? Total is going to be n by 3 plus 2n by 3. What is the answer? N by 3 plus 2n by 3, which will goes to 3n by 3, which will goes to n. Can you help me now? First level non-recursive term is n. Second level also non-recursive term is n. Indication that, please remember, recursion is always like that. First level, second level non-recursive term is not changing. First level, second level non-recursive term is not changing. Means every level same will come. First level, second level non-recursive term differ, right? I think series coming. This method, substitution method is same. In the substitution method, one time only will substitute. So straight line will come, unary tree will come. But in the case of the recursive tree method, more than one time you substitute, you will get some tree. That may be binary, that may be ternary, depending upon the problem. To get the more clarity, let me go for one more round. 2 rounds I done, you know very well. 3 rounds you have to do. Substitution method, this one same. There also 3 rounds, here also 3 rounds. Let me do one more round. N by 3 square is there. Left multiply by 1 by 3. What is the answer? N by 3 cube. Right multiply by 2 by 3. What is the answer? 2n by 3 cube. But n by 3 square will take n by 3 square time. Same way here also. This will take 2n by 3 square. This is also same, 2n by 3 square. This is also same, 2 square n by 3 square. Like that it is also divided like that. Can you help in a third level cost? Add all the non-recursive term. This one, this one, this one, this one. All 4 things add. Can you say below is 9? Okay. Above n plus 2n, 3n. 3n plus 2n, 5n. 5n plus 4n, 9n. Can you say what is the answer? 9n by 9. Right? N will come. Everyone now. First level, second level same means. Right? Everywhere same will come. It is the 3n by 3. 3, 3 cancel n k. So every level n is coming. Every level is n is coming. That is fine. Right. I think binary tree is coming. That is also okay. Can you help me one small? If you observe clearly, right? Left is always multiplied by 1 by 3. Right is always multiplied by 2 by 3. You know very well. Multiply by 1 by 3 is nothing but divide by 3 by 1. Divide by 3 by 1, which is nothing but divided by 3. So left is always you are dividing by 3. If you want, you can check. Left always divide by, see, multiply by 1 by 3 is nothing but divide by 3. N by 3. N by 3 square. Right? N by 3, n by 3 square, n by 3. If I continue like this one, what is the answer? N by 3 power k. Because always divide by 3. If left is always divided by 3, if you divide by 3 by 3 by 3, isn't that k times I done? It will become n by 3 power k. Right, right is what? Right is always multiply by 2 by 3. Multiply by 2 by 3 can be written as, if you want, you can check n by 3 by 2. Multiply by 2 by 3 is nothing but divided by 3 by 2. This is also same story. What is the answer? N by 3 by 2 whole square. Right? So this one I think it will continue. If you continue like this one, right is always divided by 3 by 2. So it is nothing but n by 3 by 2 whole power k. K times you done. Left is always divided by 3. So right is always divided by 3 by 2. Right, like that. Now can you help me one small line now? Left I always divide by 3 by 3, n by 3, n by 3 square, n by 3 cube and so on. If I do k time, n by 3 power k. Right? If I do k time, it will become n by 3 power k. Let me write now. So can you help me one small one? After doing k times, you are stopping y. After doing k time, I stopped. The reason is, see this one. The reason is n by 3 power k became 1. That is the reason I stopped. After doing k time, I stopped. What is the reason? N by 3 power k becomes 1, which is nothing but n is equal to 3 power k, which is nothing but log n base 3 is equal to k. K is log n base 3. So what is the meaning? I think after doing k time, what is the k value? Log n base 3. After doing log n base 3 time, it is stopped. Next one, can you help me one small now? Right is always divided by 3 by 2, 3 by 2, 3 by 2. Right? So after doing k time, what is k? N by 3 by 2 whole power k. Why I stopped here? This became 1. Let me write n by 3 by 2 whole power k is equal to 1. That is the reason I stopped, which is nothing but n is equal to 3 by 2 whole power k, which is nothing but log n base 3 by 2 is equal to k. K is equal to log n base 3 by 2. Right? So here k, what is the k value right side? Log n base 3 by 2. Can you help me now? Left height, log n base 3. Right height, log n base 3 by 2. Why left height is log n base 3? What is the reason? Left is always divided by 3. If you always divide by 3 by 3 by 3 by 3, log n base 3 will come. Why right is log n base 3 by 2. If you divide always by 3 by 2, 3 by 2, 3 by 2, height becomes log n base 3 by 2. Can you say left and right you are dividing equally, unequally, unequally. Left always divided by 3. So left height is log n base 3. Right is always divided by 3 by 2. Right height is going to be log n base 3 by 2. You are dividing differently, different heights came. Can you help log n base 3 is the left height, log n base 3 by 2 is the right height, it's okay. Can you help you only say log n base 3, log n base 3 by 2, which is bigger. Log n base 3, log n base 3 by 2, everyone know, 3 by 2 means 1.5, base is small means big value. Log n base 1.5, log n base 3, log n base 3 is the very small value, log n base 1.5 is big value. What is the meaning? I think he stopped here, see this one, he stopped here, but he is still going, see this. Right, see this one, log n, I think this is the log n base 3 height, it is going to be log n base 3 by 2. Everyone know log n base 3 by 2 big, right, fine. So, left height is going to be log n base 3, right height is going to be log n base 3 by 2. So, log n base 3 is smaller, log n base 3 by 2 is bigger. So, means he stopped here only, see this one, he stopped here only. He stopped here only, but he is still going because this value, this k is bigger. Some people are asking, so always divide by 3 log n base 3, always divide by 3 by 2 log n base 3 by 2, it's okay. Then what about middle people? Middle people are sometimes divided by 3, sometimes divided by 3 by 2, indication that they will be, I think, sometimes always divided by big number then small, always divided by small number then more. It is in between, a combination of both, I think indication that remaining people little bit bigger, little bit smaller. Comparing this person, they are smaller. Comparing this person, they are bigger. They are in between. They are in between. Can you help left height log n base 3, right height log n base 3 by 2. That's okay. Can you help first level cost n, second level cost n, third level cost n. Can you say fourth level cost n? You have to add all you add. All you add then n. Can you help this level cost n? That is okay. Can you help this level cost? What is the answer? This is also n. Right, it is also n. Now can you help if I go further, what is this level cost, right? When I want to add all these people, right? When I came to this place, when I want to add all these people, but this person saying that I am not there, don't add me. Until now I added, right? In every level, everyone I added, see this one. In this level, everyone I added nk. In this level, everyone I added nk. But in this level, I want to add all, then only n will come. But he is saying that I am not there, don't add me. So what is the answer? I think it is going to be less than n, but I am writing n, means upper bound I am writing, upper bound n. If I add all, need not be equal to n, but upper bound is n. Next one, if I go further, few more people are missing, upper bound is n. If I go further, few more people are losing, upper bound is n. Actually is not n, upper bound is n, right? Like that I continued, so this is also big O of n. He stopped, but still, right, I counted further also. See, below not there, below not there. Below these only there, but they are not there. Even though they are not there, I counted. Until here, see this one. Until now, until here, there is no big O, there is no omega, because the reason is every level n. Exactly n. But when it is going after this, right, less than n, because some people are missing at the less than n, that is the upper bound n I written. Right, upper bound is n means what? Actual answer is either n or less than n. Right, what is the next level? Upper bound is n, because some more people are missing. All are there n, some people missing. Right, upper bound n and so on. Can you help me now? Can you help me? If you really comfortable, see the right side. Right side every level is n. How many levels are there? Log n base 3 by 2. So finally, what is the answer? Every level n, like that, log n base 3 by 2 time. Right? So then can you help me once more? Every level is n, like that log n base 3 by 2. Can you say this is the exact answer or upper bound? Upper bound, big O of. It is the upper bound. Some people are asking, sir, why upper bound? See, here some people are not there. See, here gap is there. Still I counted. Every level, see one, I counted still. I counted, even though some people are not there, I counted. So upper bound is n. Some people are asking, what is the actual answer? Suppose, assume that you are not added anything extra, right? You are not added anything less. Exact answer is Tn. See this one, exact answer is Tn. Some people are asking, why exact answer is Tn? See this one, Tn is this is Tn. Actually, as it is, if you take, as it is, if you don't add anything less, if you don't add anything extra, if you don't delete anything also, then Tn. Because of I added little bit extra in the below levels, right? So comparing Tn, this is little bit bigger. n log n base 3 by 2. Now see the one more interesting line. See the one more interesting. Can you help me now? Left height log n base 3, right height log n base 3 by 2. Can you say left and right which is bigger? Left and right which is bigger? Right is bigger, left is smaller. Can you help me now? What is the every level? What is the every level value? First level n came, second level also n came, same. First level n came, second level n came, third level also n came, fourth level also n came, and so on. Right? This level also n came. Everywhere n. Can you help me? If I stop here, what happened? If I stop here, you only say, if I stop here, right, some things are you are leaving. Right hand side, some more people are there, but still you are leaving. Assume that I stop here. Every level is n, like that log n base 3. So what is the answer? N log n base 3. Right? Comparing actual answer Tn. What is the Tn? Tn is not more. Tn is going to be this side is less, that side is more. Overall is called Tn. Right? I think I stopped at small place only. Even though right hand side some more people are coming, I am stopping here only. What is the meaning? Comparing actual answer, this answer is smaller. The actual answer is Tn. Comparing Tn, this n log n base 3 is smaller. Comparing Tn, this n log n base 3 by 2 bigger. Some people are asking, sir, what is the Tn? This is the Tn. See this one? Same diagram I am writing roughly. See this one. Left is log n base 3 like this. Right is log n base 3 by 2 like this. Remaining all in between like this. So this is the actual diagram. This entire answer. This is the actual answer. This entire story is called Tn. This entire story. This diagram only if you calculate, that is the Tn. Now what I done in the case of the big O? In the case of upper bound, what I done? Right hand side is more height, left hand side is less. So what I done in the case of big O? Right also I added extra. See this one. This area not there, I added. This is called n log n base 3 by 2. This is, right? So only yellow color if you take care, that is the actual. For the yellow color, if I add this particular red, right, this color also, this total is called as, right, upper bound. Suppose, see this one, suppose if I cut here itself, right, this is going to be n log n base 3 lower bound. This only lower bound. This entire thing is upper bound. Only this yellow color if you see, that is the Tn. Now can you say final answer? What is the answer? Tn is middle person. Comparing this, n log n base 3 by 2 is bigger. Comparing this, n log n base 3 is smaller. But one thing I want to ask you, comparing Tn, this is bigger. Comparing Tn, it is smaller. But everyone know, these two differ by only constant, because here also n there, here also there. Right? Here log n there, here also, but here base 3 by 2. You know, log n base 2, log n base 3 asymptotically equal. Right? Because of that reason, I can say theta also. Both are asymptotically equal. Indication that all three are asymptotically equal. Mathematically, maybe they differ. Asymptotically, they are equal because constant only difference is there. Final answer. Let me write now. Final answer. Tn is equal to theta of n log n. Forget about base. Right? If anyone asks you what is the base, you can keep any base because all are differ by only constant. To this problem, what is the final answer? Upper bound is n log n base 3 by 2. Lower bound is n log n base 3. Because both differ by only constant. Simply you can say theta of n log n. Can you say what is the answer of this problem? N log n, right? N log n. Theta of n log n. Upper bound n log n base 3 by 2. Lower bound n log n base 3. Differ by only constant. You can write theta. You can keep base whatever you want. Can you say left height log n base 3, right height log n base 3 by 2. Why? Left always divided by 3, right always divided by 3 by 2. Can you say which one is more height? Log n base 3 by 2. If you take even the left less height is there, isn't that left also like right only? That is called upper bound. Comparing left and right, left smaller, right is bigger. Isn't that right also small? That is called lower bound. If you take more, that is called upper bound. If you take less, that is called lower bound. If you don't take anything, that is called actual answer, that is the Tn. Some people are asking, sir, why are you going to the upper bound, lower bound? Actual answer finding is difficult here. That is the reason I went for upper bound, lower bound. Can you say what is the difference between substitution method, recursive tree method? Substitution method, one time only you will substitute. Now here, right, more than one time you have to substitute because more than one recursive call. See here, 2, right, here I think this is replaced by 2 function call. Again here 2, again here 2. Every time 2, 2 you are subtracting. So binary tree is key. I am thinking that you are almost okay. I'm thinking that some people are asking left and right not equal. How can you say theta? Left and right differ by only constant. That is the reason I am saying theta. Otherwise, I may not say that. Final answer Tn is theta of n log n. Base 3 also you can keep. Base 3 by 2 also you can keep. Both are correct. Right. See the next problem. Recursive tree method, example 2. One more problem. If anyone thinks that such small doubt is there in the previous problem, you can clarify here. Tn is equal to Tn by 2 plus n. Tn is equal to Tn by 2 plus Tn by 2 plus n. Two function call, right? So non-recursive term is everywhere n. See, non-recursive term is everywhere n. If n there, it is n, then n. If it is n, this n. Please be careful. If it is n by 2, n by 2. That is the meaning of this reconciliation. N will be divided into two parts, it's okay. Non-recursive term, here n is there, here n will come. Right? Please be careful. What is the difference between this problem, previous problem? Previous problem, unequally you are dividing. Now here equally you are dividing. How you are dividing? Left multiply by 1 by 2, right multiply 1 by 2, which is nothing but left divided by 2, right divided by 2. Right? This is going to be very easy. Let me check. Can you how to solve this problem? How to solve the recursive tree method problem? Nothing there. 3 times you substitute, which may be contain 4 levels, including first level, 4 levels will come. 3 times you substitute. When you substitute first time, 2 level tree will come. Substitute one more time, 3 level. One more time, 4 level tree. See this one. It is taking long time, more time, it doesn't matter. To get the always correct answer, best idea. Don't go for any shortcut. Minimum 4 level diagram you write. Afterwards, automatically answer will come. If you don't do that, small mistake may happen. Minimum 4 level diagram you write. Afterwards, almost answer is came. Right? Let me start now. N will be divided into 2 parts. Right? Non-recursive. Here n is there. Here n will come. Please be careful. I am starting. See this one. N. This n. Right? This n. N is this one. This n will be divided into 2 parts. What is the left side? N by 2. Right side also n by 2. N will be divided into 2 parts, n by 2, that's okay. But here n is there means non-recursive term, n will come. Like substitution method only. Substitution method we will write one array tree, here we will write the binary tree, nothing there. Right, next one, in the similar way, if you are comfortable with this structure, whatever I done until now, same thing here, what is the answer? N by 2. Whatever is there, divide, right, left divided by 2, right divided by 2. Same thing right there in the similar way. Whatever is there, left divided by 2, right divided by 2. What is the answer? N by 2 square. This is also n by 2 square. But whatever is there, right as it is. This is also same. Left divided by 2, right divided by 2. Whatever is there, right as it is. Right? If we add both, if n by 2, if we add both, what is the answer? 2n by 2 means n. N by 2 plus n by 2, right? Total non-recursive term, if you add, because 2 times you substituted, 2 non-recursive terms came, you add them, n came. So, I think can help, first level, second level non-recursive term is same or not? Yes, same, right? If you want, you can check, next level also same will come. If you want, you can check, let me check that also, right? 4 level diagram you have to write, 3 levels over, 4, one more level. Left divided by 2, right divided by 2, same, n by 2 cube. It is also n by 2 cube. Same thing will come, n by 2 square. Here also same, here also same, here also same. Extreme things we expand, leftmost one, rightmost one expand, middle things are middle only. They may not give anything, right? Leftmost one, rightmost one expand, right? Can you help in what is the answer? N by 4, 4 times, which will goes to 4 n by 4, which will becomes n only. I think n by 2, 2 times n by 2, right? N only. So everyone know this one, everyone know. First level, second level, non-recursive term is same. Further also same will come. If you want, you can check further also same will come. Can you help me if you are comfortable? Can you say left is always divided by 2, right? If you continue k time, what is the answer? N by 2 power k. If I do 1 time n by 2, if I do 2 time n by 2 square, if I do 3 time n by 2 cube, if I do k time n by 2 power k. So, right. After doing k time n by 2 power k. Some people are asking why you stopped. This value becomes 1. That is the reason I stopped. Why it became 2 power, right? 1. What is the answer? N by 2 power k is equal to 1. N is equal to 2 power k. Log n base 2 is equal to k. K is log n base 2. Same thing like whatever you done. Can you say what about right? Right also always you are dividing by 2. What is the answer? N by 2 power k. What is the k value? Same. What is the answer? Log n base 2. Can you help? Left height, right height, same or different? Both are same. Because left also divided by 2, right also divided by 2. Left height, right height same. Can you say left height log n base 2, right height log n base 2? Can you help me now? Right? So left height, right height is both are equal, that's okay, fine. What is the every level non-recursive term? What is the answer? Every level n. Every level n. Every level n. You are not taking more, you are not taking less. In the previous problem, right, I am sometimes I will take more, sometimes I will take less, but here everywhere n, right, everywhere n. How many times? Left height, right height same. So what is the answer? Log n base 2. So finally what is the answer? The actual answer is Tn, right? So every level is n, like that log n base 2, n log n base 2, right, n log n base 2. This itself is upper bound, this itself is lower bound also, because the left height, right height is same. Finally you can say theta of n log n. Theta of n log n. Previously left height, right height is not equal. Left and right is asymptotically equal, mathematically not equal. But here left and right mathematically also equal, asymptotically also equal. So finally previous answer, this answer is same. Previous also n log n, here also n log n. Previously asymptotically n log n, right? But here mathematically n log n, because both are same height. Previously upper bound is n log n base 3 by 2, right? Lower bound is n log n base 3. Both are asymptotically equal, theta you can write. But here upper bound, lower bound, n log n base 2. So theta you can write. Previously theta, here also theta. Previously mathematically not equal, asymptotically equal. Here mathematically also equal. Mathematically means asymptotically also. Asymptotically doesn't mean that mathematically. Previous one asymptotically but not mathematically, but here, right, mathematically means asymptotically also. Previously left and right heights differ, that is the reason upper bound, lower bound came, but here both are exactly same. So upper bound, lower bound is same, right? It is the second problem. See how much easy it is. Previous problem, this problem same. The only thing is previously left and right little bit difference, but here left and right exactly same. See the next problem, example 3. See the next problem, example 3, Tn is equal to T n by 5, T 3n by 5, some problem. Tn is equal to Tn by 5 plus T 3n by 5. It is a nice one, right? Comparing previous two problems, this is little bit interesting. Tn is equal to Tn by 5 plus T 3n by 5 plus n. It is a given problem. How to solve it using recursive tree method? I will explain now. Tn is equal to Tn by 5 plus T 3n by 5 plus n. Can you say what is the meaning of this one? Left multiply by 1 by 5, right multiply by 3 by 5. But one thing, here n is there, non-recursive term n will come. Left multiply by 1 by 5, right multiply by 3 by 5, non-recursive term n, if n is there. Next one, some people are asking, what is another way of saying? Left multiply by 1 by 5, which is nothing but left divided by 5. Right multiply by 3 by 5, which is nothing but right divided by 5 by 3. Right? I think everything is fine. I am starting. Please be careful. I am not equally dividing. I am unequally dividing. Some problem may come. You have to take care. Right? I am starting. See this one. I am starting. N. This n. Divide into two parts. What is the left 2? N by 5. Left multiply by 1 by 5. Right 2. 3n by 5. But one thing, these two are completed. So n there, non-recursive term n came. In the same thing, if you really understood what is happening here, if you really understood, same thing let me repeat further levels also. What is the answer? N by 5. What is the answer? Left multiply by 1 by 5. What is the meaning? N by 5 square. Right multiply by 3 by 5. What is the answer? 3n by 5 square. Whatever is there, right as it is. N by 5. Same thing here. 3n by 5. Left multiply by 1 by 5. 3n by 5 square. Right multiply by 3 by 5. 3 square n by 5 square. Here also, as it is, you write 3n by 5. Can you help me? What is the first level? Non-recursive term n. Second level, add this. N by 5, 3n by 5. How much? N by 5 plus 3n by how much? What is the answer? 4n by 5. First level n came, second level 4n by 5 came. In the previous two problems, if you observe, first level non-recursive term n came, second level also non-recursive term n came, right? I think first level, second level same came. Series not coming, same thing is coming. Now first level, second level differ. What is the meaning? Series coming. You know very well, substitution method also same thing happening. Either series will come or same will come. First level, second level non-recursive terms are same. Means same is not coming, no series. differ series coming. If you want to know which series, if you want to know, go next level also. Minimum three rounds you do, which is nothing but 4 level tree. Let's do one more round. N by 5 square. What is the answer? Left multiply by 1 by 5, right multiply by 3 by 5. What is the answer? N by 5 cube. This is going to be 3n by 5 cube. Right? Same thing, right? Middle people also. Middle people don't bother. Extreme things you take care. Next one, 3 square n by 5 cube. Next one, 3 cube n by 5 cube. Right? If you want, you can add all of them. Same thing will come. This is as it is. This as it is will come here. This also as it is. This also as it is. Add all of them. Below is 25. What is the above? Below is 5 square. What is the above? N, 3n, 4n. 4n plus 3n, 7n. 7n plus 9n. Right? 16n. I think it is going to be what is the answer? 16n by 25. Right? 16n by 20. Below 25, above 16 there. 16n by 25. First level, second level is differ means series coming. Some people are asking, sir, which series? If you want, you can check. Some series going on. Which series? It is 4 by 5n. It is going to be, if you want, you can check. Right? 4 by 5. 4 by 5 whole square n. 4 by 5 whole power 1n. It is going to be 4 by 5 whole power 0n. It's look like 4 by 5 series. 4 by 5 whole power 0n, 4 by 5 whole power 1n, 4 by 5 whole square n, and so on. It is keep on continuing. And so on it is continuing. Right? Now can you help me now? Can you help me now? Right? So let's see the extreme left and right. Right? Left hand side, if you observe, always divide by 5, 5, 5. If you always divide by 5, after continuing k time, n by 5 power k will come. If you always divide by, this is a multiply by 3 by 5, divide by 5 by 3. If you always divide by 5 by 3, what is the answer? N by 5 by 3 whole power k. If you always divide by 5 by 3, right, after k time, right, n by 5 by 3 whole power k. If you always divide by 5, right, n by 5 power k. I think everything is fine now. Let me check. Can you help me now? What is the right height? Always dividing by 5 by 3. This will goes to, if you want, you can check k value, right? Log n base 5 by 3. If you always divide by 5, so what is the answer? Left height is going to be log n base 5. K is equal to log n base 5. Left height is going to be log n base 5. Right height is going to be log n base 5 by 3. Right? And one more thing. Log n base 5, log n base 5 by 3, you only say which is bigger. Log n base 5, log n base 5 by 3, which is bigger? Log n base 5 by 3. 5 by 3 means 1 point something, but it is the base 5. Base bigger means small. What is the meaning? Left height is going to be small, right is going to be bigger. Isn't that? This may be the case. What is the meaning? I think he stopped here, left person is stopped here, right person is still going. See this. Middle people, always, see this one, always you are dividing by bigger number this side, you are always dividing by smaller number here, these are in between. Always big divide, small came, always small divide, big came, in between people. Right? I think everything is fine now, right? Fine. Now can you help me now? Left and right, which is the more height? Right hand side. And one more thing, in this tree, where is the gap? Because of left stopped early, right is still going. I think gaps are on the left side. Here, see, some gaps are there. Here, no one is there. He is still going, right hand side person is still going, right? Left person is already stopped. Few gaps here, right? Please be careful. Who is the more? Right side. Left is going to be smaller. Please be careful. Now see the answer. Can you help me now? If you see right side, see the right side. What is the first level non-recursive term? 4 by 5 whole power 0n, 4 by 5 whole power 1n, 4 by 5 whole square n, and so on. Can you help me if I continue like this one? What is the last term in this series? But one thing is true. If you add all, then you will get this. See this one. You add all, then you will get. You will add these, then you will get this. If you add these all, what is the answer? Maybe 4 by 5 whole cube n you will get. Next one, 4 by 5 whole power 4n you will get, and so on. If I continue like this one, what is the last one? 4 by 5 whole power log n base 5 by 3 n will come. But one thing, if I add all, then only series term will come, right? Because of some people are missing here. By adding all, right, series term may not come, less than that may come. But anyhow, I took upper bound here. right? Until here no problem, series is coming. But when you go below, these, because of these people are missing, if I add all of them, series term may not come, less than that will come, but still I will take upper bound. So this is the series, right? All you have to add. Previously also I am adding, now also this one. This entire series I have to add. Previously also I added, because previous addition is easy. Why? N plus n plus n plus 5 times 5n. N plus n plus n plus log n time n log n. Previously also I added, now also I added, but here different terms, right? Series came. Previously no series, addition becomes easy. Now series is there, addition becomes difficult. Let me try now. I am trying this. See, let me add all these things. See this one. Comparing Tn. Right hand side all the things if I add, right? I think right, these all if I add, definitely more will come. What is the reason? Even though some people are not there, those also I included. That is the reason right hand side more will come. Comparing Tn, right hand side people are more. Who are those? 4 by 5 whole power 0 n. 4 by 5 whole power 1 n. And so on. What is the last one? 4 by 5 log n base 5 by 3 n. Right? This is the series. See, last few terms are actually not exactly, right? They are little bit more, because even though some people are missing, I consider it as they are part of the series. Even though they are actually less than that, I consider it because I want to take upper bound. This entire series you will solve, you will get the upper bound. Comparing Tn, this is a little bit bigger. Let me check here, less than or equal to n common. Remaining 4 by 5 whole power 0, 4 by 5 whole power 1. And so on. What is the last one? 4 by 5 whole power log n base 5 by 3. Now one more interesting thing, right? In the last class we done, right? In the last class we done, please be careful. In the last class we done n into. Can you see, is it GP series? In the previous lecture we done, is it GP series? Right? I think so a power 0, a power 1, a square, I think it is a GP series. In the GP series, R value is less than 1 or more than 1. R value is 4 by 5, it is less than 1. GP series where R value less than 1, if you add all of them, you will get some constant. Some constant, that may be 4, that may be 3, whatever it may be. If you add all of them, if you want, you can verify. Some constant you will get. Finally, it will goes to what the answer? Less than or equal to n, which will goes to big O of n. Right? Tn is big O of n. Okay. Some people are asking, Tn is equal to big O of. Some people are asking, sir, how it is possible? First level itself is n. If I add all of them, how can I get n? Right? First level itself n. If I add all of them, you will get some constant into n. What is the reason? I think it is decreasing. See this one. 4 by 5, right? Whole power 0 means 1. It is the 1 into n. This is 4 by 5, which will goes to what the answer? 5 8 is 40, I think 0.8. It is the 1n, it is the 0.8n. 0.8 whole square, what does that mean? 0.64 means n decreasing. If you add all of them, right, you may get some constant into n. Please be careful. So to this problem, upper bound is big O of n. Series is until here. Some people are asking, upper bound is big O of n, it's okay, but what about lower bound? Let me check here. Lower bound means what? Until here only concentrate. Even though some more people are coming down, don't bother them. Right? Until here only concentrate. Can you help? Actually I have to consider afterwards also, but I will stop here. What is the meaning? Less I will get. So let me check this one. Tn greater than or equal to. What is the reason? Comparing actual answer, if you consider only this part, until here only, less will come. So Tn is bigger that time. Let me write now. 4 by 5 whole power 0 n. 4 by 5 whole power 1 n. And so on. What is the last one? 4 by 5 whole power log n base 5, because always divide by 5, right? This will goes to greater than or equal to n common. Remaining 4 by 5 whole power 0, 4 by 5 whole power 1, and so on. Lastly 4 by 5 whole power log n base 5, right? Greater than or equal to some n into everyone now. It is also GP series, right? R value less than 1. If you want, you can calculate, you will get constant. Right? Finally, it is going to be what the answer? Greater than or equal to n. Finally, which will goes to what the answer? Omega of n. So can you help to this problem, lower bound n, upper bound also n, So I think upper bound, lower bound both are same. You can write theta also. Tn is equal to theta of n. Upper bound also n, lower bound also n. Some people are asking, Some people are asking, sir, this series is until log n base 5 by 3. That series is until log n base 5. How can you say both are equal? Try to remember, this series also will give one constant. This series also will give one constant. These two constants may not be same. This may be small constant. It may be assumed that 2. It may be 5. This will give bigger, this will give smaller, because series is, right, series if you see very less terms are there, here more terms are there. But because of it the decreasing GP series where R value less than 1, here also constant came, here also constant came, here small constant came, here big constant came. So here big constant into n, here small constant into n. But if you see asymptotically constant doesn't matter. So upper bound is going to be n, lower bound is going to be n, you can say theta. Please be careful, it is a nice problem. Some people are thinking that, here n, next level also n, next level it is not necessary. Right? Problem to problem, these may change. First level n came, second level not n came. First level, second level same is coming. Differ, series coming. Just solve that series, you will get this answer. And one more, in the previous class I said to you, decreasing GP series. What is the meaning? GP series R value less than 1. That is called decreasing GP series. If we add the, if we solve the decreasing GP series, total becomes one constant. Outside n there, n into constant. Here also n into constant, but this series contain very less term, this series contain more term. Here bigger constant will come, here smaller constant will come, but difference by only constant theta. So I think until now if you observe clearly, right, 3 problems I mentioned to you, 3 problems I done. Right? So this problem answer is going to be n, previous 2 problem answer n log n, I think so, right? Please check. Any small doubt is there, please take. This problem, first problem almost similar. First problem also unequally divided. This problem also unequally divided. But the problem is in the first problem, every level value if you add, n coming. But here, every level value is not n, right? Some difference is there. Here series came, in the first problem series not came. But in the second problem, equally you divided. Every level same came, right? Like that. 3 different problems. You please take care about these 3. If any problem is given indirectly, directly, these only. Right? Fine.
Right. Example 4. 3 examples over, almost you are okay. Let's see this example also. Example 4. Tn is equal to t n by 2 n by 3 t n by 4 plus c, where c is a constant.
Tn is equal to Tn by 2, Tn by 3, Tn by 4 plus c, where c is a constant. So what is the meaning? If I give n non-recursive term, c will come. If I give n by 2 non-recursive term, c will come. If I give n by 10 non-recursive term, c will come. Please be careful. And one more, n will be divided into 3 parts. 1, 2, 3. Right? Let's start. This problem also will give more clarity. Please be careful. So n, this n. Right? This n divided into 3 parts. Left side is multiply by 1 by 2, right side multiply by 1 by 3, right, left side multiply by 1 by 2, middle multiply by 1 by 3, right side multiply by 1 by 4. Multiplying by 1 by 2 is nothing but divided by 2 by 1, means 2, 3, 4, like that. So n divided into 3 parts, right, it will take c time, non-recursive term is c. Next one, this also again 3 parts. What is the answer? First time is 1 by 2, next 1 by 3, next 1 by 4. What is the answer? N by 2 square. N by, multiply by 1 by 3, 6. This one, n by 8. Whatever is there, 1 by 2 into, 1 by 3 into 1 by 4. Right? So this will take c time. Here also same. C. Here also same. Right? C. So if you want, I will write here n by 8, n by 12, n by 4 square. N by 4 square. Right? Fine. I think what is the second double cost? I think 3c is 3c. And one more thing in the last class also I said to you, now also I am saying to you. See this one. Don't remove the small constant. when you are doing recursive method or substitution method, until 3 rounds, write as it is. Don't delete anything. Don't add anything. Until 3 rounds over. Don't add anything. Don't delete anything. As it is you write. Don't do any simplification also. In the final answer, you can do simplifications. Final answer, you can write upper bound. Final answer, you can write lower bound. In between, don't do. Until 3 rounds, at least don't do. Right? Please be careful. So, first round is C came, second round 3 C came. First level, second level, something difference there. Means I think same is not coming, series coming. Same is not coming, series coming. Please be careful. Once again, let us see here. Once again, this one also. What is the answer? Divide into 3 parts. It will take C time. Then what is the answer? It is going to be n by 2 cube. It is going to be already n by 4 into 2. Right? I think into 1 by 2 means 2 cube. It is going to be 4 into 3, 12. I think this one, what is the answer? N by 4 into 1 by 4 means n by 4 square maybe, 16. Same thing here also. You know very well. Same thing like previous. Here also 3. Here also 3. Here also 3 like that. Right? Here also 3. Right? Let me ask one. So let me do the extreme. Extreme left, extreme right is my goal. Can you say what is the n by 4 square? This is going to be what is the answer? Into n by 16 into 1 by 2. What is the answer? 32. 16 into 2, 32. This one, n by 16 into 3, 48. Next one, n by 4 square there, it will become 4 cube. It will also take C time. Now add all of them. What is the answer? I think 3. Every 3 will give 1 more 3. 3 times 3, I think 9C. If you want to 9 people, 1, 2, 3. Every one will give 3. Every one, 3 people, 3 3s, 9 will come. It is a 9C. First level C, second level 3C, next one is 9C. Right? Like that it is going on. Some people are asking me, right? 4 level tree I constructed. Then what is going on? Series coming, you know. Which series? You can see very well. What is the answer? 3 power 0C, 3 power 1C. I think it will become 3 square C. Next one, if you want, you can check 3 power 3 cube C and so on. It will continue like this. Now, can you help me now? Can you help me now? Here, left there, middle there, right there. What is the left? Left always divided by 2. Middle always divided by 3. Right always divided by 4. Can you help me now? If you always divide, left is always divided by 2. If you always divide by 2, if I do 3 times n by 2 cube, 2 times n by 2 square. If I do k time n by 2 power k. Next one, right is always divided by 4. If I do 3 times n by 4 cube, 2 times n by 4 square. If I do k time, what is the answer? N by 4 power k. Now, can you help me? What is the left height? You only say, what is the left height? Same. If you always divide by 2, by 2, by 2, you know very well. What is the k value? Log n base 2. If you divide always by 4, by 4, by 4, what is the answer? Log n base 4. Middle is log n base 3, that is okay. K value here is log n base 4. Right, left height is log n base 2, right height is going to be log n base 4. You only say left and right, which one is bigger? Which is bigger? I think log n base 2, log n base 4, base 2 is bigger. Why? Base is small, big value will come. Base is big, less value will come. What is the meaning? This may be the case. If I want to say, right, little bit better way, this may be the case. This is the diagram. What is the meaning? He stopped here, but he is still going. I want to say that left is bigger. Middle person, I think everyone, log n base 3 is in between. Log n base 2 bigger, right? Log n base 4 smaller. Log n base 3 is in between. In between are they? Right? Remaining people are in between. Right? So that is bigger, this is smaller, remaining people are in between. It is a ternary tree. Please be careful, it is a ternary tree. Right, ternary tree. Now can you help me one small one? What is every level? Let's give. I think because of this side is bigger, it will give upper bound, that will give lower bound, it is going to be middle. Right? Let's check here. Let's check. Can you help me? What is the first level? 3 power 0C. Second level 3 power 1C. Third level 3 square C. Fourth, right, 3 power 4C and so on and so on. Until here you take. Until here. So some people are asking, sir, below not there, how can you take? If you take until here, even though some people are not there, that is called upper bound. You know very well from first problem onwards. This is going on. Let me write now. Tn is the actual answer. If you don't take more, if you don't take less, that is the Tn. Right? Comparing Tn, this side is right. So actually it is not a complete binary tree. Complete binary tree means no gap. But here if you observe this one, here gaps are there. See this one, here gaps are there. This area is gaps. right? He stopped here itself. This person is stopped here itself, right? So if you add this also, that is called as upper bound, right? You know very well. Tn is less than or equal to, what is the series? 3 power 0c, 3 power 1c, 3 square c, and so on. What is the last one? 3 power, what is the left height? Log n base 2c. Less than or equal to, c common, 3 power 0, 3 power 1, and so on, 3 power log n base 2. Right? Less than or equal to some c into, you know very well, it is the GP series where r value is more than 1. R value is more than 1. So you have to calculate. What is the answer? A into 1 into r power 3 power, how many times? Log n base 2 minus 1 by r minus 1. Minus 1 plus 1, don't bother. Right? This is going to be less than or equal to some c into bigger function. What is the answer? 3 power log n base 2. Which will goes to, forget about c, right? N power log 3 base 2. Right? So log 3 base 2 is 1.5. This will goes to, what is the answer? Big O of n power log 3 base 2 is 1.5. Right? Like this. This is the answer. Right? For this problem, this is the upper bound. Why? Left is more height, right is less height. Right? Even though right is having less height, I am thinking that side also this much is available. So that is there is an upper bound. So to this problem, upper bound is going to be n power 1.5. Log n, here series is until log n base 2. n power log 3 base 2, which will become 3 power, right? See, this one actually 3 power log n base 2 after reversing. So c into 3 power log n base 2 after reversing n power log 3 base 2. This is the final answer. It is the upper bound. Let's see lower bound also. Right? So right is going to be less height. Let's take the less. What is the 3 power 0? Same thing. 3 power 1c, 3 square c, and so on. What is the last one? 3 power log n base 4c. Greater than or equal to some c into 3 power 0, 3 power 1, 3 square, and so on. What is the last one? 3 power log n base 4. Greater than or equal to some c into, right? So what is the a? 1. R power 3 power log n base 4 minus 1 by, right? 3 minus 1. Forget about small thing. It will goes to c into 3 power log n base 4. Right? This will goes to, what is the answer? N power log 3 base 4. Log 3 base 4, which will goes to omega of, what is the answer? N power log 3 base 4. Log 3 base 4 is going to be 0 point something, but it is going to be, right, 1 point something. Now some people, let me ask you, series is there until log n base 2. Here series is log n base 4. Some people are asking, here log n base 2 series, here log n base 4 series, right? Then why answer came difference? What is the reason? In the power it is going on. In the power, everyone know this one. Log n base 2, log n base 4 differ by only constant, you know very well. But that constant is in the power. That is the reason it became n power 1.5. If constant is below, there is no problem. If constant above, that matters. Series is until log n base 2, here log n base 4. So this is going to be big, this is going to be small, that's okay. But difference by only constant, it's okay. But in the power n square different, n cube different. So it is the upper bound, it is the lower bound, both are not equal. So theta not possible. So what is the answer? Tn is big O of n power log 3 base 2. Next one, omega of n power log 3 base 4. Here base 2, here base 4. Right? It is the upper bound, lower bound. Right? Please be careful. Right? This is the answer for this problem. Example 5. Tn is equal to T n by 3 plus T 2n by 3 plus n square. Tn is equal to Tn by 3 plus T 2n by 3 plus n square. What is the meaning? Left multiply by 1 by 3, right multiply by 2 by 3. But here n is there, non-recursive term n square. Please be careful. Let's do this also. This may give more clarity. Let's start. N, this n. Right, this n. Divide into two parts. What is the left? Multiply by 1 by 3. Right, multiply by 2 by 3. This n becomes n square. Non-recursive term. Similar way, same story repeat further. What is the answer? Left multiply by 1 by 3, 3 square. Right multiply by 2 by 3, 2n by 3 square. But here, n there, non-recursive term n square, n by 3 there, n by 3 whole square. Same way here also, left multiply by 1 by 3. What is the meaning? 2n by 3 square. Right multiply by 2 by 3. 2 square n by 3 square. This also multiply by, what is the answer? 2n by 3 whole square. Now, total non-recursive term add there. n by 3 whole square, 2n by 3 whole square, means below 9 only. But what is the above? n square here, 4n square here. Total become 5n square, right? 5n square by 9. Left one sees one, first level, second level, right? Difference is there. So, same is not coming, series coming. First level, second level differ means same is not coming, series coming. If you want, you can continue one more round. So, I think it's a binary tree only, right? Only 2 function calls. Same, what is the answer? Left multiply by 1 by 3, n by 3 cube. Right multiply by 2 by 3, 2n by 3 cube. Same here. Left multiply by 2 by 3. So, left multiply by 1 by 3. What is the answer? 2 square n by 3 cube. Right multiply by 2 by 3. 2 cube n by 3 cube. Right? This will become square here. This is also become square here. Whatever is there, square. It is also same. Right? Add them. If you add all of them, if you want, you can verify. 5 by 9. 5 by 9 whole square n square will come. It is a 5 by 9 whole power 1 n square. It is a 5 by 9 whole power 0 n square. Right, like that. Now can you help me now? Left always divide by 3 by 3 by 3. It will become n by 3 power k. What is the k value this side? Log n base 3. Next one. Right always multiply by 2 by 3. Right always multiply by 2 by 3. Divide by 3 by 2. So n by 3 by 2 whole power k. Can you say what is the k value right side? What is the answer? Log n base 3 by 2. Left is log n base 3. Right is going to be log n base 3 by 2 means 1.5. So right is more. Left is less because base 3 here base 1.5. Right is more, so upper bound will come from this side. Let's write this. Tn is actual answer. Comparing this one, upper bound, right? What is the series? 5 by 9 whole power 0 n square. 5 by 9 whole power 1 n square and so on. What is the last term? 5 by 9, right? Log n base 3 by 2, right? N square. So, log n base 3 by 2. This is the bigger one. Left is going to be log n base 3, right is going to be log n base 3 by 2. Log n base 3 by 2 is bigger. Next one. Less than or equal to n square common, right? 5 by 9 whole power 0. 5 by 9 whole power 1 and so on. Lastly, 5 by 9 whole power log n base 3 by 2. But everyone now, it is a GP series R value less than 1. What is the answer? Constant. Less than or equal to n square into constant. Finally, big O of n square. Upper bound is big O of n square. Let's see the lower bound also. Tn greater than or equal to n square common. 5 by 9 whole power 0. 5 by 9 whole power 1. And so on. What is the last one? 5 by 9 whole power log n base 3. This is the GP series R value less than 1, constant. So, n square into constant. See, both are, that is also constant, this one. This GP series total value constant, that GP series total value constant. But here, that series is a little bigger, means bigger constant. This series is a little bit smaller constant. But one thing, difference by only constant, that is not there in the power, that is there below, right? Fine. This will become omega of n square. Upper bound also n square, lower bound also n square. Final answer, Tn is equal to theta of n square. To this problem answer, Tn is theta of n square. This is the answer for this. Please see, right? Initial problem is looking like so complex, right? Now this problem became very simple. It took almost like 2 minutes just to draw, right? Minimum 4 level tree you draw. What is going on every level observe, right? Definitely 2 different kinds of trees, right? 2 different kinds of levels will come. Maybe left more, maybe right more, maybe both are equal. If both are equal, there is no problem at all because everything is that itself. Both are differ, one upper bound, one lower bound. Differ by constant or function. Differ by constant only, theta possible. Differ by function, right? Theta not possible, right? Like that. This is the 5th example. Please take care. If you open any book, I am saying to you, recursive tree method, substitution method same. Recursive tree method, you are substituting many times, substitution method one time. Because of one time, one array tree will come. Because of more than one time, right? Maybe binary tree, maybe a ternary tree is coming. I am thinking that you are really fine, right? Let's see the next problem. One more problem, let me see. Example 6. Right? Let's see this also. Tn is equal to T n by 2 n by 3 n by 4 T n by 4 plus n square. Right? This problem, what is the answer? It looks like so dangerous, really nothing there. One smaller one is there, one bigger one is there, one middle one is there. Right? Fine. Let's see roughly. What is this one? Left multiply by 1 by 2, middle multiply by 1 by 3, right multiply by 1 by 4. Minimum 4 level diagram you write. Let's check here. N 3, n by 2, n by 3, n by 4. But one thing, n is there, n square. Right? N is there, n square. Same thing here. What is the answer? 3 people. What is the answer? 1 by 2, 1 by 3, 1 by 4. 1 by 2. What is the answer? N by 4. 1 by 3, n by 6. 1 by 4, n by 8. This is going to be square. N by 2 whole square. Same thing here also. Let me check here. N by 8. N by 12. N by 4 square. This is going to be n by 4 whole square. Right? This is going to be n by 3 whole square. Add all of them. Right? Add all of them. So I think you have to add carefully. Please be careful. So add all these 3. What is the first one? First one is going to be n by 4. Right? N square by 4. Second one, n square by 9. Third one, n square by 16. Right? Find the LCM for that. 4, 9, 16. I think 4. Right? This is the, I think, LCM. So multiply on 2, 3, 6. Right? 6, 3 is 18. 18 2 is 36. 36 into 4. 144. LCM is 144. You know very well how to add. Right? 144. So I think what is the answer? 4 into 36. Same thing. 4 into 36. 36 n square. Next one. What is this one? 9. Right? So it is going to be 9. 9, I think 9, how many times it will go? 9 once 9. Next one is going to be 9 once 9. 9 6. 54. I think fine. 16 n square. Next one, it is 9 n square. Add all of them. 9, 6, 25, 36, which will goes to 25, 36. What is the answer? 30 and 20, 50, I think 61. 61 n square by 144. Right? You add properly. I am thinking that this is the answer for this. Let's check here. Add properly. If you add all these things, what is the answer? 61 n square by 144. What is the next level? Calculate properly. 61 by 144 whole square n square. It is 61 by 144 whole power 1 n square. 61 by 144 whole power 0 n square. Right, like that. Calculations do properly. I may be done wrong. Please verify. Small mistake may happen. I am thinking it is right. Right? Like that. Can you help me now? Can you help me? Left always divide by 2. Middle always divide by 3. Right? Right always divide by 4. If you divide always by 2, by 2, by 2, what is the answer? Log n base 2 left side. What is the right side? What is the right side? Always divide by 4. What is the answer? Log n base 4. Which one is smaller? Log n base 2 smaller. Right? Now let me add. Series, let me add. Tn less than or equal to n square common. Remaining, what is the answer? 61 by 144 whole power 0. 61 by 144 whole power 1. And so on. Lastly, 61 by 144 whole power log n base 2. Right? And one more thing, it is the GP series where R value less than 1. Same story.
n square into big O of 1. Finally, big O of n square. I think omega also same, please verify. N square into constant of 1, right? Omega of n square. Finally, theta of n square. Please be careful, nothing there in this problem like previous problems only. The only thing is n by 2, n by 3, n by 4. He will give larger height, he will give less height, he will give middle don't bother. So this will give larger one, this will give upper bound, this will give lower bound because of decreasing GP series, difference by only constant. So theta also possible. So to this problem, answer is theta of n square. Right? Please be careful, it is giving ternary tree. Minimum 4 level diagram you write. Right? Almost like how many examples? 6 examples I said. They are more than enough. All the problems carefully analyze. Substitution method I said approximately 12 problem. This is 6 problem. Please take care. To solve recurrence relation, we see in substitution method and recursive tree method. There is one more method that is called as master theorem. Right? Master theorem. To solve the recurrence relation, this is the one more way. But the problem with this method is, see this one, problem with this method is any recurrence relation which is there in this format, Tn is equal to At n by b plus f of n. Any recurrence relation which is there in this format, then only master theorem will be applicable. Any recurrence relation which is there in this format, then only master theorem will be applicable. Where A and B are constants, A greater than or equal to 1, B greater than 1. B greater than 1. B should be greater than 1. If at all B is not greater than 1, assume that B is 1, assume, right? Tn. If B is equal to 1, Tn calling Tn, then where is the recursion? Recursion means what? A function calling that itself. It's okay. But one thing, to solve bigger one, right, you have to call smaller one. It should be small. But whenever there is no division, where is the concept of small? Right, there may be a chance that it will keep on calling, right, without ending. Anyhow, so if you want to apply master theorem, right, so recurrence relation should be in this format where A and B are constants, A greater than or equal to 1 and B greater than 1. And one more thing is going to be f of n is positive function. F of n is positive function, means greater than 0. This value should be equal to, this value should be greater than 0. Positive function. Any recurrence relation which is there in this format, master theorem will be applicable. Right, fine. So I am thinking that you are little bit okay. Let's go to the conditions, rules or conditions, whatever it may be. Rules of the master theorem or conditions of the master theorem. Right, see this one. First one. If f of n is equal to big O of n power log a base b minus epsilon, if f of n is equal to big O of n power log a base b minus epsilon, where epsilon is constant and epsilon greater than 0. Right? If f of n is big O of n power log a base b minus epsilon, where epsilon is constant greater than 0, then Tn is equal to, can you help you know, if f of n is big O of n power log a base b minus epsilon means, right, which side is bigger? Big O means what? Right side bigger, means this side is bigger, then Tn is equal to theta of whoever is bigger, that will be the answer. Forget about this epsilon, afterwards we will talk. Tn is equal to theta of n power log, whoever is bigger, that will be the answer. That is the case 1 of the master theorem. It is the case 1. Instead of saying rules, it is better to say case. Right? Case 1 of the master theorem. Let me write. It is the case 1 of the master theorem. Let's go for 2. Case 2 of the master theorem. Case 2 of the master theorem I am writing. See the case 2 of the master theorem. if f of n is equal to omega of n power log a base b plus epsilon, where epsilon is constant greater than 0, right, where epsilon is constant greater than 0, and one more thing, and one more condition is there, and one more condition is going to be regularity condition also you have to satisfy. Regularity condition also you have to satisfy. And one more thing, see this one, if f of n is omega of this one, and regularity condition also satisfied, regularity condition also satisfied. Regularity condition also satisfied, then answer is going to be, can you help me know according to second case which is bigger? Omega means I think left side is bigger, then answer is whoever is bigger, that will be the answer. If f of n is omega of n power log a base b plus epsilon, where epsilon is constant greater than 0 and regularity condition also should be satisfied, then answer is going to be T of n is equal to theta of f of n. That is the case 2. See the case 3. See the case 3 of the master theorem. Tn is equal to theta of n power log a base b into log n whole power k, where k is constant, k greater than or equal to 0. Case 3 of the master theorem, Tn is equal to theta of n power log a base b into log n whole power k, where k is constant greater than 0. Then Tn is equal to, theta means what? Both are equal. Then answer is going to be theta of n, because of both are equal. Then Tn is equal to theta of n power log a base b into log n whole power k there, just write k plus 1. Right? These are the 3 cases. These are the 3 cases of the master theorem. Case 1, case 2, case 3. What is the case 1 saying? Big O. Means right side is bigger, that will be the answer. Case 2, left side is bigger, that will be the answer. Case 3, both are equal. Then take right hand side person because of both are equal. Then take the right side one, just right side one k there, just write in the answer k plus 1, that's it. Right, that's it. So I think master theorem is simply 3 cases. Master theorem is simply 3 cases, please be careful. Right, and one more thing I want to ask you, see this one, just I am explaining also. Right, some students are thinking that master theorem is very difficult. No, in total algorithm subject, easy one is master theorem only. I am starting now. See, master theorem, whatever theoretical things are there, I written on the board. Only for namesake I written. Without writing also I can explain. Just I want to make sure that it is better to write. That is the reason I written. It is better to write, that is the reason I written. So now let me start explaining. Very simple, let me start explaining. Can you say what is the only problem with the master theorem? What is the only problem with the master theorem? The problem with the master theorem is going to be any reconciliation in that format, then only master theorem will be applicable. Otherwise master theorem is not applicable. And next one, any reconciliation in that format master theorem you can apply, that is okay. 3 cases you have to remember. They are very easy also. They are looking like very difficult, they are very easy. They are very easy, please be careful. Right? Some people are asking, sir, how they are very easy? I will explain. See this one, how they are very easy, I am explaining now, please see this. See carefully. You only say, if you have this reconciliation, Tn is equal to At n by b, please listen, Tn is equal to At n by b plus f of n. If you have this reconciliation, you only say, by seeing this reconciliation, can you say, what is the a value? Yes, whatever is there in this place, that is the a. What is the b value? Whatever is there in the b place, that is the b. Using these two, just find out n power log a base b. If in the master theorem reconciliation is given, you want to solve that reconciliation using master theorem. Is it there in this format or not? You check. Yes, it is there in this format, assume. Then find a place, what is there. Find b place, what is there. Using those two, find out n power log a base b. Next one. Right? Find f of n also. In that reconciliation, what is the f of n? Right? N power log a base b, compute.
from the given information, f of n also, whatever is there in the f of n place, that also, now I think everyone know. Master theorem is nothing but comparing, right, f of n and n power log a base b. Master theorem is nothing but comparing f of n and n power log a base b. What the case 1 is saying? N power log a base b bigger, that is the answer. Case 2 saying f of n bigger, that will be the answer. Case 3 saying theta. Theta means both are equal. If both are equal, then take the right hand side thing. Just if here k there, just write k plus 1. That is the master theorem saying. Master theorem is very simple. As soon as you see the master theorem kind of recurrence relation, just find a and b value. Using them, find out n power log a base b. Afterwards, f of n also, compare both of them. By comparing, you have to take care. Whichever is bigger, he will be the answer. If at all he is bigger, he will be the answer. If at all he is bigger, he will be the answer. Please be careful. That's what the three cases. That is the reason master theorem. See this one. Some people are thinking that master theorem is very difficult. You only say, if master theorem is very difficult, I could have copied from book this entire story. If I want to explain master theorem, assume that is really tough. Assume that, right? Then I could have copied everything, all case 1, case 2, case 3 from the book itself. But I am not done because that is very easy. That is the only reason. Right? Just to find out a and b, from that n power log a base b, find out f of n also, whatever is there, take, just compare. After comparing, whichever is bigger, that will be the answer. Case 1, n power log a base b bigger. Case 2, f of n bigger. Because why it is bigger? Big O. Why it is bigger? Omega. Why both are equal? Theta. Right? Like that, three cases. Now listen, one more interesting answer. See the one more interesting answer. So can you help me now? In the case 1, f of n and n power log a base b, who is bigger? In the case 1, f of n and n power log a base b, who is bigger? N power log a base b bigger, that's okay. See this one, this is bigger, it's okay. See the interesting answer, this is bigger, it's okay. See this one, n power log a base b minus epsilon, which is nothing but n power epsilon. F of n is equal to big O of n power log a base b. Right, minus epsilon in the power is nothing but, right, n power a minus b means n power a by n power b. So this is nothing but n power log a base b by n power epsilon, where epsilon is a constant greater than 0. What is the meaning? Where epsilon is a constant greater than 0. What is the meaning? N power epsilon, where epsilon is a constant greater than 0. Indication that this is polynomial. Nothing there. Listen, nothing there. N power log a base b, if I divide by polynomial, n power log a base b, if I divide by polynomial, then both are equal. Can you help me now? What is the case 1 of the master theorem saying? Case 1 of the master theorem saying that comparing f of n power log a base b bigger. That is fine. Comparing f of n power log a base b bigger. And one more, that n power log a base b which is bigger, if you divide by polynomial, then f of n and n power log a base b both are equal. What is the meaning? N power log a base b, if you divide by polynomial, you are getting f of n. Indication that n power log a base b bigger by polynomial time. Now it is something like this one. If someone will divide me by 20, then I am equal to something else. What is the meaning? Someone will divide me by 20, right? Then I am equal to something else. Indication that I am 20 times greater than that one. I am explaining now. There is some y, right? If someone will divide me by 20, right, then I am equal to y. What is the meaning? I am 20 times greater than y. That is the reason, if someone will divide me by 20, then I am equal to y. Same way here. N power log a base b is bigger. If you divide n power log a base b by n power epsilon, where epsilon is a constant greater than 0, means n power log a base b, if you divide by polynomial, then I am equal to f of n. Indication that n power log a base b bigger by polynomial times. Please be careful. Case 1 saying that n power log a base b bigger. Not only that, bigger by how many times? Polynomial times. Why? By dividing by polynomial, f of n power log a base b both are equal. Case 1 saying that not only who is bigger by how much. So case 1 saying that n power log a base b bigger by polynomial times. Please be careful. See the case 2 also, interesting answer. See the case 2 also. If you see the case 2, right, n power log a base b. What is the meaning of plus in the power plus is nothing but n power log a base b into n power epsilon, where epsilon is constant greater than 0. What is the meaning? Can you help in the case 2? Who is bigger? F of n. In the case 2, f of n bigger means who is smaller? N power log a base b smaller. In the case 2, n power log a base b smaller, because of e is smaller, multiply by polynomial, then it is equal to f of n. Case 2 saying that n power log a base b smaller, but this one if you multiply by polynomial, then it is equal to f of n. Indication that n power log a base b smaller by polynomial time. Case 1 saying that n power log a base b greater by polynomial time. Case 2 saying that n power log a base b smaller by polynomial time. Right? Please be careful. Can you help me? According to case 1 of the master theorem, what is the answer? N power log a base b is polynomial times greater than f of n, then answer is n power log a base b. Case 2 of the master theorem, n power log a base b is polynomial time smaller than f of n, then answer is going to be, right, f of n. Right, next one, case 3 saying that both are equal. If both are equal, then whatever is there on the right side, right, just in the power k, just write k plus 1, right, something like that. Now I am repeating once again. Someone will ask you from today onwards, right, for this particular recurrence relation using master theorem, solve it. Then what will you first do? What is the first step you will do? F of n compute from the recurrence relation. A value, B value, using that n power log a base b compute. Then compare both of them. Right? Case 1 saying that n power log a base b polynomial times bigger. Case 2 saying n power log a base b polynomial times smaller. Case 3 saying that, right, both are asymptotically equal, right, something like that. So if anyone still facing the difficulty, when I am explaining the problem, you will get more clarity, right? Let's see the first problem. If anyone having small doubt also, there is no need to remember also. Whichever is bigger, what is the meaning of here remembering? Whichever is bigger, mostly that will be answer. But one or two precautions are there, please take care. I am repeating once again. Can you say to solve the recurrence relation, how many methods are there? 3 methods. Substitution, recursive tree method and master theorem. Among all these 3 methods, which one is going to be taking very less time? Master theorem. That is the reason it is called as master theorem. It is a master, means it will take less time. Some people are asking, sir, if at all this method is taking very less time, then why previous 2 method? What is the reason for that? Master theorem is applicable only those recurrence relation in the form of at n by b plus f of n. In that format, then only master theorem. Other than that format, you have to go to substitution method or recursive tree method. When the recursive tree method, more than one function called recursive tree method. Anything substitution method. In this format, master theorem. In all these 3 methods, right, if anything possible by master theorem, that will take very less time. To get the clear clarity why it is taking less time and all, let's have few problems, right? Take the first problem. From now onwards, please be careful. If anyone saying that master theorem I didn't get until now, if anyone saying like that, I didn't said anything until now. First problem I am saying, it is very simple also. Whatever you got, it's okay. Can you help me now? Case 1 of the master theorems, can you say in the normal English line? Case 1 of the master theorem, technically I written, that's okay. Can you say in the normal English line? Case 1 of the master theorem saying that n power log a base b bigger than f of n polynomial times. Case 2 of the master theorem saying that n power log a base b smaller than fn polynomial time. Case 3 master theorem saying that both are equal. Something like both are equal. Any difference is there, I will clarify that also. You always remember, sometimes, right, right, I don't want to confuse you by saying big statement. Whatever possible, that point of time I will say. Right? Slowly, if I say anything, if you think that some small thing I am doing wrong and all, no, I am not doing, correct time I will bring that point also. My interest is going to be not only saying the true things and all, I have to make sure that you should get. So, if any small things are going, definitely I will rectify. Maybe tomorrow I will rectify. Right? Maybe day after tomorrow I will. Correct time I will bring that point also, you don't worry. Right? I am thinking that everything is fine now. Let's start this. Right? See the first problem. Very simple now. See the first problem, example 1. Example 1, see the answer. Tn is equal to 8t n by 2 plus n square. It is the recurrence relation, right? This recurrence relation using master theorem, how to solve? Let me check here. This one. What is the A? 8. What is the B? 2. Right, that is fine. Right, A is there, B is there. Now let's see this one. What is the f of n? Can you help me? A is there, B is there, it's okay. What is the f of n? Can you help me now? F of n is n square. Right, everyone, it is just compare with this. A t n by b plus f of n. Compare with that. Now f of n is n square. Next one. What is the n power log a base b? Log 8 base 2. What is the answer? N cube. Can you help me now? Comparing f of n and n power log a base b. Who is bigger? Comparing f of n and n power log a base b. See the master theorem also. Left is f of n. I written same. Right is n power log a base b. I written in the similar way. Similar format I written. Left is f of n. Right is n power log a base b. Can you help me now? Always we will talk about right only. Left f of n. Right is n power log a base b. We will always talk about right only. Let's come to the right. Right, can you help me now? Right hand side is bigger or not? Yes. Comparing left to right is bigger or not? Means big O, first case. Yes, right, it is bigger. Can you say it is bigger? It's okay. Divide by what? So that I will get the f of n. What is the answer? Divide by n, then I will get. Divide by n, then I will get. What is the meaning? N power log a base b is bigger, right? N times than f of n. What is the meaning? N is a polynomial. N power log a base b bigger n times than fn. That n is a polynomial. Linear means polynomial also. Everyone know. So n power log a base b bigger polynomial time than f of n. Then which case of the master theorem? Right? Which case of the master theorem? First case. Then what is the answer? Whichever is bigger. Right? That will be the answer. N power log a base b bigger than f of n. N time means polynomial time. Right? So I think case 1 of the master theorem. Then what will be the answer? Whoever is right, because of he is bigger by polynomial time, whoever is bigger, that will be the answer. Answer is going to be Tn is equal to theta of n cube. Right? The n power log a base b is n cube. If you divide this one by n, then you will get this. What is the meaning? He is bigger by, right, n times than f of n. N is a polynomial. Right? So I think case 1 of the master theorem, then answer is going to be, right, whoever is bigger. I think n power log a base bigger, that will be the answer. That is the first problem. Just find out a value, b value, right, using that find out n power log a base b, this, f of n, n square, then I think n power log a base b bigger, right. If I divide by n, then I will get f of n, means he is bigger by, he is bigger comparing with fn, n time. N is a polynomial, means he is polynomial time bigger. Case 1 of the master theorem. Answer is n power log a base b is the answer, that is. That is the example 1. If anyone still facing the difficulty, let's go to the example 2. You will get the more clarity in this. Example 2. See this. Tn is equal to 2tn by 2 plus n square. Now can you help me from this? Don't worry about the answer. From this, let's start. What is the f of n? N square. What is the a? 2. b? 2. What is the n power log a base b? What is the answer? Log 2 base 2n. Now always we will talk about right only. N power log a base b only we will talk. Can you help me now? This person is bigger or smaller? N power log a base b is smaller or bigger? Smaller. I think case 2 of the master theorem. This person is smaller, everyone know. N power log a base b smaller, it's okay. Can you help me now? If it is smaller, what I have to multiply so that both will be equal? I have to multiply by n. N power log a base b is n, means he is smaller, that's okay. What I have to multiply so that, right, left and right both will be equal? You have to multiply by n. N is a polynomial, indication that n power log a base b is polynomial times smaller than f of n. So case 2 of the master theorem. Then what is the answer? Right, it is going to be, previous one is case 1, it is the case 2 of the master theorem. In the case 2 of the master theorem, what is the answer? Whoever is bigger is the answer. Who is bigger? After multiplying by n, then both are equal. Means he is smaller, means he is bigger. Whoever is bigger, that will be the answer. Tn is equal to theta of n square. Whoever is bigger, that is the answer. That is the case 2. Just f of n and n power log a base b compare, that's it. See, here I multiplied, here I divided. Here why I divided? It is bigger, that is the reason I divided, so that both are equal. Right? Here why I multiplied? It is smaller. I multiplied so that both are equal. Right? Fine. I am thinking that you are really okay. Those people who are really troubling, see this example also. Example 3. Guarantee you will get now. See example 3. See this. T of n is equal to
T of n is equal, let me check here, T of n is equal to 2t n by 2 plus 2t n by 2 plus, right, n, right, see this one, T of n is equal to 2t n by 2 plus n, right, it is the reconciliation, please listen, interesting one. Can you see f of n? It may be trouble you have to listen, f of n, a value 2, b value 2, n power log a base b, what is the answer? Log 2 base 2 n, both are equal. Can you help me now? If both are equal, which case of the master theorem? Third case. See, third case is visible, please see there. That is the third case, it is visible also, see this. So both are equal. Now can you help now? What the third case is saying is, carefully listen. What the third case is saying is, both are equal, it's okay. Both are equal, it's okay. See this one. It is the f of n. It is the n power log a base b. Both are equal, that's okay. Can you help me? According to third case, what you have to do is, f of n left side, it's okay. See this one. F of n left side, it's okay. N power log a base b right side, that is okay. Both are equal, that is also okay. Fine. Right? Now, what the third case is saying is very simple. See this one. What the third case is saying is, please listen. Left is n, right is n, both are equal, it's okay. According to third case of the master theorem, what you have to do is, right side person, you have to write something like log n whole power something, so that both are equal. Can you help me now? Already both are equal. You have to write log n also whole power something where whole power k, where k greater than or equal to 0. 0 also you can write. Write something log n whole power something, so that both are equal. You only say already both are equal. But according to master theorem, third case saying that compulsory you have to write right side log n whole power some k greater than or equal to 0, so that both are equal. Already equal. If you keep 0 also, then both are equal. Then if you can satisfy, see this one, it cannot be case 1. See, some people are asking, when I will go to case 3 of the master theorem, case 1 fail, case 2 also fail, means both are equal. Yes, both are equal. Right? When you come to the case 3, compulsory right side you have to keep log n whole power something, so that both are equal. Already both are equal. But according to rule, you have to write log n whole power something also, so that both are equal. By keeping 0, both are equal. Then answer is going to be, careful listen, then answer is going to be, see this one, then answer Tn is equal to theta of whatever is there right side, right as it is. Right? But in the place of 0, write 0 plus 1. Right? That will be the answer. Whatever is there right side, write same thing. But in the whole power, what k there, just write k plus 1. These are the three cases of the master theorem. What is the first case? N power log a base b polynomial time bigger than f of n. Case 2, n power log a base b polynomial time smaller than f of n. N power log a, case 2 saying that n power log a base b is polynomial time smaller than f of n. Case 3 saying that these two fail. Case 1, case 2 fail. Then go to case 3. Right? What is the case 3 saying? That case 3 is saying that by right hand side, by adding log n whole power something, just make both as equal. Log n whole power something, by keeping, just make both as equal. Then answer is going to be whatever you kept on the right hand side, just in the place of k, just write k plus 1. Right? Please be careful. That is the third one. Right? I am thinking that you are little bit fine now. Let's come to the next one. 3 examples I done. I am thinking that you got some idea. Some idea is okay. Some people are saying that, sir, I didn't get clearly what master theorem. Nothing. Master theorem contains 3 cases. Right? Those 3 cases, right? Just to do meaningfully 1 or 2 times. 3 problems I done. Let me do 3 more problems. You will get more clarity. See this. One more problem I am doing. Example 4. See the example 4. You only will give answer. Let me check here. Tn is equal to 16 T n by 4 plus n. 16 Tn by 4 plus n. This is the given problem. Let's see now. Easily you will give the answer. Fn n. A 16, B 4, n power log a base b, log 16 base 4. What then 16 can be written as 4 square, right? So n power log 4 square base 4. What is the answer? N square. Can you help me now? Just go right side and talk. Always our concentration right only. Please help me now. Right side I came. I am asking, this person is greater than comparing f of n or not? Yes, is greater. If he is greater, what I have to divide so that both will be equal? Divide by n. So, right hand side, if you divide by n, then both are equal. What do you mean dividing by n? What is the n? Polynomial. Means right hand side person is polynomial term bigger than left hand side person. Then what is the answer? Answer is going to be, whoever is bigger, that is the answer. Answer is going to be Tn is equal to theta of n square. Whoever bigger, that will be the answer. If you want to solve this problem, I am saying to you using substitution method, it may take approximately 10 minutes or 5 minutes. But using master theorem, 1 minute, compare both of them, whoever is greater, that will be the answer. Right? I am thinking that example 4 also okay. Let us see the example 5. See this example 5 also. Example 5. Tn is equal to, make sure that if you are comfortable, 32 T n by 2 plus n power 6, some value, right? Let's check here. Fn, what is the answer? N power 6. N power log a base b. What is the answer? N power log 32 base 2, which will goes to n power 5. Now we will talk about right only. Can you help He is bigger or smaller? Right only our goal. He is bigger or smaller? He is smaller. N power 5 is n power 6. He is smaller, that's okay. What I have to multiply so that both are equal? I think n. I have to multiply by n, then both are equal. Multiplying n, this n is a polynomial or not? Yes, indication that right hand side person is polynomial times smaller than f of n. Right? So, master theorem second case. Then what is the answer? Answer is going to be whoever is bigger is the answer. Theta of n power 6. That is the right case 2 of the master theorem. And one more. In examination, no one will ask you which case it is. They will simply give recurrence relation. They will ask what will be the answer. They will give simply recurrence relation. They will ask what will be the answer. Right? They don't ask master theorem also. Whatever method you want, you can do. See the recurrence relation? Okay, master theorem is easy, then go there. If you think that a master theorem is not possible, then go for substitution. You decide whatever way you like. No one bothered about which case and all. I am thinking that you are little bit okay, right? Let me say one more problem. Example 5 is over. See the example 6. See the example 6 now. Be careful about this also. Example 6. Tn is equal to example 6. It will trouble you if you don't listen. See this one. Right? So, example 6. Tn is equal to T n by 2 plus, right, Tn is equal to Tn by 2 plus n log n. N log n. This is the given problem. Some people are asking what is the answer. I will clearly explain. Please take care. Listen everyone. Listen everyone. What is the Fn? What is the Fn? N log n. Fn is n log n. Can you help What is the n power log a base b? A is 1, b 2. Right? This will goes to n power log 1 base 2, which will goes to n power log 2 power 0 base 2, which will goes to, what is the answer? N power 0. So, n power log a base b is going to be, what is the answer? N power 0. What is the meaning of n power 0? What is the meaning? 1. Constant. Now, I think always your goal is right side. Come right side. F of n is n log n. Right? What is the n power log a base b? 1. Right side only your goal. Can you help Right hand side person is greater or smaller? Right hand side person is greater or smaller? I think he is smaller. Some people are asking he is smaller, it's okay. He is smaller by how many times? He is smaller by how many times? Say right hand side person is smaller, it's okay. He is smaller by how many times? How many times? I think he is smaller by, left is n log n. He is smaller by n log n time. He is smaller by n log n. Right? Right hand side person is smaller, it's okay. Smaller by how many times? N log n time. Can you help In the n log n, n is there or not? In the n log n is there, means polynomial time. Try to remember n polynomial, n square polynomial, in between also polynomial, don't worry. N polynomial, n square polynomial. So, n is there, that is enough. So, right hand side person smaller by how many time? Polynomial time. What is the reason? N log n, if I multiply, then I am equal to left side. So, n is there. Log n is there, it's okay. N polynomial, n square also polynomial, in between also you don't worry. Minimum polynomial required. More is there, it's okay. N polynomial, more is there, what is the problem?
right? So try to remember this one. Right hand side person is smaller by n log n time. In the n log n is there, so polynomial. So this person is polynomial times smaller. So what is the answer? Whoever is bigger is the answer. Tn is equal to theta of n log n. Right, this person, whoever is bigger is the answer. Please take care. It is a nice problem. Right hand side person is smaller. How many time? N log n time. In the n log n is there, means polynomial. Right hand side person smaller by polynomial time. So according to master theorem, what is the answer? Whoever is bigger is the answer. That is the example 6. I'm thinking that everything is okay. See, these many problems I covered. See this one, I think it is the first problem number 1, problem number 2, problem number 3, problem number 4, problem number 5, problem number 6. Please take care, all the problems one by one. See, 1 or 2 problems are pending, let me do those also. Example 7. Right, example 7. See the answer, interesting one. Tn is equal to, it will really trouble you if you don't listen. See this one, Tn is equal to 2tn by 2 plus n log n. Tn is equal to 2tn by 2 plus n log n. It will really trouble you. Listen everyone. Interesting point is coming. So can you help me now? In this problem, what is the Fn? N log n. Fn is n log n. That's okay. Can you help me now? What is the n power log a base b? N power log 2 base 2. What is the answer? N. Fn is n log n. N power log a base b is n. Interesting answer. Everyone listen. So come to the right side as usual. Come to the n power log a base b right side. Ask the right side person, are you smaller or bigger? Smaller. Right hand side person I am asking, are you smaller or bigger? He said that, yes, I am smaller. Can you help me? He is smaller, it's okay. He is smaller, it's okay. Smaller by how many times? What I have to multiply so that both are equal? He is smaller, fine. But smaller by how much? So that, right, if I multiply, I will get the left hand side person. He is smaller by, I think, log n time. If I multiply by log n, then both are equal. Can you help me now? Can you help me now? In this problem, right hand side person means n power log a base b. Log n times smaller than Fn. Is it written? N power log a base b comparing f of n, log n times smaller. Try to remember, log n is not polynomial. Log n is not polynomial, right? Polynomial means what? N power some constant which is greater than 0. N power some constant which is greater than 0. Please be careful. That is called polynomial. N polynomial, n square polynomial, in between also okay. N log n also okay. N cube also okay. N power 1 lakh also okay. But one thing, minimum polynomial should be there. See this one, it is the less than polynomial, logarithmic. N power log a base b smaller than f of n, logarithmic time but not polynomial time. What is the meaning? Case 2 of the master theorem failed. Case 1 no chance because he is not bigger. N power log a base b bigger polynomial time than case 1. N power log a base b smaller polynomial time than case 2. So case 1 fail, case 2 fail. This problem, case 1 fail because he is not bigger. Case 2 fail. What is the reason? He is smaller by logarithmic time but not polynomial time. But I want polynomial time. So case 1, case 2 fail. Then you have to go to case 3. What is the case 3 actual purpose? Both are equal. Case 3 actual purpose is left and right both are equal, then case 3. Case 3 having one more advantage also, I will say now. Both are equal, then go to case 3. Case 1, case 2 fail. Let's go to case 3. I have only one option now, case 3. Let me check the case 3. Can you help me one small line now? Can you help me now? Left hand side n log n there. See this one? Left hand side n log n there. What is the right side? N there. Case 1 fail, case 2 fail, it's okay. Now come to the case 3. Left hand side n log n is there. Right hand side n is there. That's okay. Now what the case 3 of the master theorem saying is, just go right side, right hand side whatever they, for that multiply by log n whole power something so that both will be equal. Left is n log n, right is only n. But case 1, case 2 fail. I came to case 3. What the case 3 saying is, right hand side whatever is there, n is there. Multiply by log n whole power some k which is greater than or equal to 0. Just keep some k value so that both will be equal. I think if I keep the k value 1, then both are equal. Then answer is going to be Tn is equal to theta of. What is the answer? Right hand side whatever is there, take all log n. Here 1 is there, 1 plus 1, 2 right. This is the answer for this. Now it is the correct time to ask, when will you go to case 3 of the master theorem? When will you go? Right? Polynomial term bigger fail. Polynomial term smaller also fail. Right hand side person, polynomial term bigger fail, polynomial term smaller fail. Then go to case 3. Case 3 having two choices. What is that one? If both are equal, then also case 3 will work. Right? One more is going to be, right? Right hand side person, logarithmic time smaller. You multiplied means what? Smaller. Right hand side person, logarithmic time smaller, then also case 3 will work. Polynomial time smaller, polynomial times bigger, case 1, case 2. Case 3 saying that right hand side person, polynomial time smaller only, not bigger. Right hand side person is logarithmic time smaller than case 3. Both are asymptotically equal, then also case 3. Case 3 having two choices. What is that one? Both are equal, then also case 3. Right hand side person logarithmic time smaller, then also case 3. Here, right hand side person logarithmic time smaller, then case 3 will work. Then what is the answer? Whatever you kept k, just write k plus 1. This is the example 7. Example 7 answer, n into log n whole square. N into log n whole square, right? This log n whole square. I am thinking that your example 7, you are absolutely fine, right? So can you help me know what is the k value? 1, right? Just 1 plus 1, 2 you write. Some people are asking what are the k boundaries? K greater than or equal to 0, any number you can take. I think k value 1 I took, then both are equal, then answer is k plus 1. I am thinking that example 7 also you are okay. See the example 8. See the example 8 now. It may trouble you, please listen this also. Example 8, see this one, example 8. I am writing the necessary things. Example 8, see this one. There is some recurrence relation. See, assume that some recurrence relation. Example 8, there is some recurrence relation. See this one, in this recurrence relation, let me write Fn. Careful listen, in this recurrence relation, Fn, just let us assume that Fn is like this one, n into log n whole power 9. It is a Fn. Right? In this recurrence relation, some Fn, n into log n whole power 9. Next one, n power log a base b. N power log a base b. Assume that this is n. Fn is this much, n power log a base b this much. Let me ask you, go right hand side, ask, can you help me? Is it smaller or bigger? Smaller. Smaller by how many times? Log n whole power 9. Log n whole power 9 time right hand side smaller. Can you help me now? Is it smaller by how much? Log n whole power 9 time. Log n whole power 9 is polynomial or less than polynomial? Right? This is not polynomial, it is a logarithmic. What do you mean? E smaller by log n whole power 9, which is the logarithmic time smaller but not polynomial. What is the meaning? Case 1, case 2 fail. Polynomial time smaller, polynomial time is bigger, case 1, case 2. Right? E is the logarithmic time smaller. Right? Indication that I think case 1, case 2 fail, case 3 came. Is the logarithmic time smaller? Now can you help me now? What I have to multiply so that both are equal? Then what is the answer? Log n whole power 9 multiply, then both are equal. Right? If at all, log n whole power 9 if you multiply both are equal, logarithmic times is smaller, then answer is going to be T of n is equal to, what is the answer? Theta of n into log n whole power 9 plus 1, 10 is the answer. That is the example 8. I am thinking you are okay. Now, I am saying one more small line, otherwise it may be trouble you, I am saying this also. See the example 9. See the example 9 now, otherwise it will trouble you. See this, Tn is equal to, see the answer. Otherwise let us assume that some recurrence relation. Right? Don't concentrate anything about the recurrence relation, just you have to know the point. See this one. Example 9, one recurrence relation there. Assume that it is one recurrence relation. Some recurrence relation, whatever you want, you can write. Assume that in this recurrence relation, Fn is like this. Careful. In this recurrence relation, everyone listen. In this recurrence relation, Fn is like this. Fn is n. And one more. N power log a base b. Assume it is possible or not possible, it is a different story. One recurrence relation is there, it may not be possible also. No need to explain, but I want to say that point clearly. Example 9, one recurrence relation there. Right? It may not be possible also, I am saying again and again. Right? That is the again and again I am saying, just I am giving one example. One recurrence relation there. In this recurrence relation, assume Fn is n. N power log a base b. Assume that. N power log a base b. Assume that. N into log n whole square. Assume. N power log a base b is this much. F of n is this much. Now go to the right side. It may not be possible also. Assume that sometimes possible. Assume. So n power log a base b, n into log n whole square. Can you help me now? Just come right hand side, ask him. Are you bigger or smaller? Bigger. How many times? Log n square time bigger. So right hand side person, log n square time bigger. Log n square means what? Logarithmic. So he is bigger by logarithmic time. Can you help me now? Case 1, case 2 fail because they want only polynomial. Right? You came to case 3. Can you help me now? Case 3 you came is logarithmic times bigger than Fn, it's okay. Can you help me now? Right? Can you help me now? Right? What I have to multiply so that both will be equal. What is the answer? This is the n power log a base b. What I have to multiply? Case 3 saying that multiply log n whole power some k so that both will be equal. Can you say what should I write? Log n whole power minus 2 so that both will be equal. But right, according to master theorem, right? If you want, you can go there. According to master theorem, third case. This is the third case. See this one. It is the third case. See, where k is constant greater than or equal to 0, 0 only, negatives not allowed. Negatives not allowed. Please be careful. Where k is constant greater than or equal to 0, negatives not allowed. Only positives. So can you help me now? I think here positive I written, k value 1 I written, right? So next one more problem, right? I think k value 9 I written, that is also okay, right? But here k value minus 2 I should write. It is the n power log a base b, k value minus 2, it is not possible. This is not possible. So try to remember. Case 3 saying that, right? Both are asymptotically equal, it's fine. Next one, n power log a base b, logarithmic times smaller only. Logarithmic times smaller only, then only write case 3. Equal also okay, n power log a base b, logarithmic times smaller, then also okay. Logarithmic time bigger, it is the logarithmic time bigger, that is the reason minus 2 means whatever dividing. It is the logarithmic times bigger, logarithmic times smaller, then only master theorem, right? Try to remember, right? F of n is this one, n power log a base b is this one, right? Master theorem is not possible. Master theorem not possible. F of n is this one, n power log a base b this one. This is the bigger. How many times? This one is bigger. How many times? Log n square time bigger. What I have to multiply so that both are equal, right? Because of it the logarithmic times bigger. Master theorem not possible. Logarithmic times smaller possible. See, this is the example. Right? This example 8. Logarithmic times smaller because of smaller multiplied. See this. Next one, this also. Logarithmic times smaller than this is. Now one more problem we done already. Which problem it is? I think example 3. See this one. Both are equal. Equal also okay. Equal also okay. Next one, third, it is the case 3. It is the case 3 of the master theorem. Equal also okay. One more thing is logarithmic times smaller is okay. One more problem. Logarithmic times smaller is okay. That is the case 3. Right? But logarithmic times bigger, master theorem don't work. This is the, what is the example? Example 10. I am thinking that you are almost comfortable. Let's go to the example 10. Small thing is pending. Example 10. See the example 10. Tn is equal to, example 10. Tn is equal to, see this one. 2 power n t n by 2 plus Tn is equal to 2 power n t n by 2 plus n square, some number. Right? This is, right, recurrence relation assume. Can you help me now? What is the f of n? N square. What is the n power log a base b? Which will goes to n power log 2 power n base 2, which will goes to n power n. So f of n is n square. N power log a base b is going to be n power n. That is okay. Can you help me now? Can you help me now? Is n power n is bigger? Right hand side only our goal. Is it bigger? Yes. It is bigger. Bigger by how much? Bigger by how much? Suppose assume that is bigger by n time, it's okay. Is bigger by n time, it's okay. N square time, it's okay. More also okay. Not less than polynomial. This person is bigger by polynomial or more than polynomial, it's okay. It cannot be less than polynomial, right? It cannot be logarithmic term. Logarithmic term, third case. Is bigger, polynomial or more than polynomial, it is okay. If you want, you can check it is the n square, it is the n power n, is bigger by n power n minus 2, means polynomial or more than polynomial also, no problem. Right, please be careful. Polynomial doesn't mean that polynomial. Minimum polynomial. Is a minimum polynomial time bigger? Yes. Then what is the answer? Whoever is bigger, right, that will be the answer, everyone know. But here, master theorem is not possible. Actual answer is bigger comparing with f of n. Polynomial or more than polynomial? Yes, true. Then answer is whoever is bigger is the answer. That is also okay. But master theorem here not possible. Why? Can anyone help? What is the reason? The reason is A should be constant. See the definition. A and B are constants. A is here function, right? It should be constant. It should be constant. It should be constant. That is the reason master theorem is not possible. This is example 10. It should be constant. That is the reason master theorem is not possible. That is example 10. Let's go to the one more problem. Example 11. One more nice problem coming, please take care. Example 11. See this one, interesting one. Example 10. Tn is equal to, see this one, Tn is equal to T root n plus c, where c is a constant. Tn is equal to T root n plus c, where c is a constant. Right? This problem using master theorem I have to solve. How? Let me check. Using master theorem I want to solve this problem. How? I will explain. Can you see, if you want to apply master theorem for this one, format should be Atn by 2. Right? There should be a division, but there is no division. Right? There should be a division, but the division is not there. Right? In this reconciliation, if I want to solve using master theorem, right, everyone know master theorem form Atn by b, division should be there, but there is no division here. Please be careful. Master theorem not applicable for minus, for the plus, right? Only for division it is applicable. But this is the reconciliation. This reconciliation, if I want to solve, right, I want to solve using master theorem. Master theorem saying that Atn by b plus f of n format should be there, but it is not there in that format. So if I want to solve this one way is going to be substitution method. So substitution method using root operator, we are already done. It may be looking like complex one. Root operator there, solving that particular reconciliation, it may be time consuming, everything possible. It may be time consuming. I want to solve this problem, root operator there, I want to solve this problem using master theorem. How? You can do substitution method, you know very well. Worst case you can apply substitution method. I am saying new procedure, how to solve reconciliation which contain root operator using master theorem. Right? I am explaining. One nice procedure is there. Please, right? Please listen one time, it is enough. How to solve a reconciliation which contain root operator using master theorem. I am giving the answer. Very simple it is. Right? See the first step. First step is going to be assume n is equal to 2 power k. Assume this. Right? If you assume n is equal to 2 power k, substitute t of 2 power k is equal to t. What is the answer? 2t. What is the next one? N is nothing but 2 power k whole power 1 by 2, which will goes to 2 power k by 2 plus, see this one, n is there replaced by 2 power k, n is there replaced by 2 power k, here c there, n and c no relation, c. Assume n is equal to 2 power k, yes, replace n by 2 power k, n by 2 power k, it became like this. That is the first assumption. See the second one more assumption. See, everyone carefully listen, assume one more, t of 2 power k, assume t of 2 power k is equal to s of k. This is one more assumption. Right? Some people are asking, sir, how you are assuming? See this one. And one more, some people are asking, how can you assume whatever way you want? You can assume whatever way you want if you do reverse. If you do reverse, you can assume A as B. Why? After some time you can replace B by A. If you do reverse also, you can assume whatever way you want, no objection. So I assumed like this, I got this answer. I will do reverse also. Next one, I am assuming this as this one, right? So I will do reverse also afterwards, don't worry. Some people are asking, sir, how you are assuming? Let me check here. Nothing. Because of I am mapping, I can map whatever I want because I will do reverse. See how I am mapping. In the power, who is there? K. That will comes to here. Remaining whatever T of 2 there, that is S. You can map whatever way you want because you are doing exactly reverse. Power whatever is there, keep here. Remaining T of 2, yes. This is the way how I am mapping. If you are okay with that, let's start. Assume T of 2 power k is equal to S of k, right? Let's substitute now. What is the answer? T of 2 power k is equal to S of k. This one, whatever is there power, it will comes to here. What is the answer? S of k by 2. And one more. T there, then only S will come. Here there is no T, so same thing will come. So it is the second step. Assume T n is equal to 2 power k, substitute here. Assume T of 2 power is equal to S of k, then once again substitute this story, this is the one. I think now if you want you can check it is came, right? Master theorem format. Can you say, in this particular recurrence relation, what is the f of k? All are in terms of k only. What is the f of k? C. Next one, what is the a? 1. What is the b? 2. What is the k power log a base b? Because all are in terms of k. Let me start. F of k. What is the answer? Constant. That may be C, whatever it is. Next one. What is the k power log a base b? Which will goes to, what is the answer? K power log 1 base 2. Which will goes to k power 0. Which will goes to constant. Right? Both are constant. Can you say both are equal? Case 1 fail. Case 1 of the master theorem fail. Case 2 of the master theorem also fail. Case 3. What the case 3 will say? Right? Case 3 will say that just go right hand side, multiply by. What is the answer? Log n whole power k. But here not log n. Log k whole power k. Something. Log k whole power something so that both are equal. I think 0. All are n's are there, log n. All are k's are there, log k. Log k whole power something, then both are equal. Yes. Then answer is going to be, what is the answer? Answer. S of k is equal to theta of, right hand side. What is the answer? Log k whole power. 0 plus 1 means 1. So this will be the answer. After 2 steps are completed, this is the answer. But everyone know, problem is there in terms of n. In terms of Tn, problem is there, but it is in terms of S of k. Now let's do the reverse, right? 2 steps are over until now. Let's see the third step. See the third step now. S of k is equal to, see everyone now, S of k is equal to, now answer theta of log k. That's okay. Now you only say, right? N is equal to 2 power k. So assume, I think, see this one. S of k is equal to theta of log k, right? The second step is over. This is the answer. See the third step. S of k is equal to theta of log k. That is the current thing available. Can you help me now? S of k. What is the reverse? Right? T of 2 power k. S of k reverse. If you want, you can check here. This is there. T of 2 power k is equal to S of k. Then S of k reverse T of 2 power k. T of 2 power k is equal to, this is replaced by this, is equal to S there, then T came. Here S is not there, as it is will come. Log k. That is the third step. Second step reverse is third step. Go to the fourth step. First step reverse. Can you say what is the first step? N is equal to 2 power k. First step, N is equal to 2 power k. Means k is equal to log n base 2. Replace now. Fourth step. Replace k is equal to log n base 2. What is the answer? T of 2 power k is equal to theta of log k. That is okay. Replace k by log n. This will become T of 2 power log n base 2 is equal to theta of log n base 2. Now this will become, what is the answer? This will become T of n is equal to theta of log n is the answer. To solve any recurrence relation which contain root operator, just do substitution method. One more way, if you want to apply master theorem, apply first 2 steps. Apply first 2 steps, first step and second step, master theorem format will come, using master theorem solve it, then do reverse of first 2 steps. Second step reverse is third step, first step reverse is fourth step, finally answer in terms of n only. This is, what is the example number? Example number 11. It is example number 11. See this. Now go to next one. One more example with this master theorem over. Example 12. See this also. If anyone having small doubt also about master theorem, see this also. Tn is equal to 2t
root n plus log n, any base. Tn is equal to 2t root n plus log n base 2. Start. Root operator there, I want to apply master theorem. Can you say first step? Assume n is equal to 2 power k. Right? Substitute now. T of 2 power k is equal to 2t 2 power k by 2 plus, what is the answer? N is equal to 2 power k. Replace n by 2 power k. Log 2 power k base 2. So k. Wherever n is there, replace by 2 power k. Right? After first step is over, this answer. See the second step. Assume t of 2 power k is equal to s of k. Standard procedure. Whichever is there in the power, keep here. Remaining t of 2. Yes. Right? Now what is the answer? It will become s of k. This one. It is going to be 2 s k by 2. One thing. T there, s will come. Here t, s came. Here t, s came. Here there is no t, k only k. So second two steps are over. Master theorem format is came. Now solve this one using master theorem. What is the answer? F of k. What is the answer? K. Next one. K power log a base b. K power log 2 base 2. What is the answer? K. Both are equal. Which case of the master theorem? Third case. What is the third case will say? Go right side. Right? Add log k whole power something, then so that both are equal. I think 0. Then answer is going to be same thing in the place of, right here 0. Just write 0 plus 1. Answer is going to be s of k is equal to theta of, what is the answer? K into log k whole power 0 plus 1 is 1. Right? Like this is s of k is equal to this one. Let's start the right third step. Third step is reverse of second step. What is the second step? T of 2 power is equal to T of 2 power k is equal to s of k. Now s of k reverse T of 2 power k. So what is the answer? S of k. T of 2 power k is equal to s there t theta of k log k. So second step reverse is third step. I completed. Go to the fourth step. Fourth step is the reverse of first step. What is the first step? N is equal to 2 power k. What is the reverse? K is equal to log n. Replace k by log n. T of 2 power log n base 2 is equal to theta of log n into log n. Finally, T of n is equal to theta of log n into log n. So to this problem answer log n into log n. What is the problem? This is the problem. 2t root n plus log n. Right? What is the purpose of 11th problem and 12th problem? See this one. 11th problem, 12th problem goal is going to be how to solve reconciliation using master theorem if it contain root operator. Right? Next one. Right? These are, I think 12 problems I said, they are more than enough. Now from now onwards, any reconciliation is given. Right? By seeing the problem, master theorem possible, apply directly. If master theorem not possible, more than one reconciliation, recursive tree method. Right? Worst case, substitution method. Most probably, substitution method I said 12 problem, master theorem I said 12 problem, recursive tree method I maybe said 6 problem. On an average, total 30 problems maybe I said. Please practice all of them without by hearting. Reconciliation solving itself, they may give for 2 mark question. Right? Fine. And one more thing, these are the basics for next chapter, divide and conquer. Right? Please you take care. Any problem is troubling you, right? Just see all the notes, see all the entire topic one more time, right? So still it is troubling you. You can ask your friends, you can ask me also, you can Google it out, you can see in the YouTube also.